All right, let's do a sound check here. Looks like sound's working. Should be good. You guys should be able to see me. We're going to be working on Ansible stuff today. We were heavily into Ansible last week, and we haven't gotten around to it again this week. I think I was mostly working in the lab the last few days and got a lot of good stuff done in the home lab, so that's kind of cool. But now Sunday mornings are all labs, so we'll start here in a minute, and we're just gonna go through Ansible labs. We're gonna keep hitting this idea of what we call the Socratic method, where we ask ourselves questions as we do things. Like, you could just do things in a lab, but then when we're done, we're gonna ask ourselves questions about like what we did, and do we understand how we did the things and how we got to, whatever we were doing. So that's kind of our goal today. I'm just going to be working on Ansible. And I'll be writing the notes over here because people always want the answers to these later when we're done. And we're all the way down in Lab 9. I've been taking notes from all the other labs, so these notes will show up in the Discord when we're all done with this. But that's where we're at. So with that, let's get down into Ansible. I know people are probably waking up, grabbing their coffee still. That's fine. Just feel free to hop in when you get a chance. I will post the links to these in the YouTube side of things, and I will pin it over on the Twitch side of things. So there we go. I'll make it 30 minutes. All right, so we're going, and the as we do the labs, you feel free to ask questions. Feel free to kind of, you can always ask questions down in Discord later if you don't want to ask them now. But as you're doing this, think about like, hey, do I understand this tool? Do I understand what we're trying to do? And those are the kind of things you want to like clarify and understand. Hey, how's it going, RNX? Hopefully this stuff's useful to you. We're working on lab stuff today. All labs on Sunday, right? And not lab stuff like working in the home lab the other day. Although I did get some good stuff done yesterday on stream, but that was one of those streams where I was just kind of hanging out working on stuff. Today we're doing stuff that's hopefully pretty useful to everybody. So let's oops, we don't want to check this lab. We want to start this lab. We're going to add in, so we're going to say cat root hosts, right? And there's our inventory there. Hey, how's it going over on the YouTube side? Nick Hill and Doc. Hopefully this stuff's useful to you guys. We're building labs and stuff. Well, labs are already built. Now we're just doing the labs. And this first one is we're going to check how Ansible can do API calls with the URI module. There's a module in there that allows you to interact with web pages and anything anything remote. So we're going to start real simple. We're going to start real simple, hitting an API, pulling out data. And then we're going to start pulling data and sending data. I'm going to show you guys a pretty advanced little lab here that I think, and I've told you guys this before, it's the hardest lab I have. But, I mean, I don't think any of them are really hard, but I think it's the most complex lab. But anyways, let's do this. So we need to create a playbook that calls this API via the URI method. So if I click on this, it takes me over here and I get some JSON output, and there's this nice little and this is a topic that I think most people probably understand. Who's this guy, Luke Skywalker? What is the Star Wars API? What is this, right? It's just an API out there that we can hit and pull data, right? One of these ideas that if I can hit it and get it to give me some data, I can do whatever I want with that data afterwards, right? So we're going to return that data out and look at it in whatever way we want. So we looked at our host file. Let's look at our little API file that I put together for you. And it looks like the normal YAML. We got our 3 dashes to let us know that it's YAML. If you have multiple 3-dash lines in a YAML file, it denotes a start of a new file, right? Come down here, and it's some arbitrary name, call API and get results from a web page. We can put pretty much whatever we want in here. The host is interesting. We don't really need a host file for this lab. We're using the local host. So we're just using the machine that we're on. We're not going anywhere, so that's good. Gather facts are still true so that we can maybe generate some time stamping and stuff like that. We don't have to become root. We're already root. And we get down into our tasks. All of our tasks are then, in YAML. This is a list now. Here's our first task. Here's our second task. We've got the names for them right here. And then the name of the module is right here. So we've got a URI module and a debug module. Those are the two modules we're using in this lab, right? Then there's arguments given to those modules that affect how they're behaved. So URI gets called, the module URI, but then the URL command tells it what to go hit. Well, that's the web page we just hit, right? The API endpoint, as you were, whatever we're doing. And then we want to return content, yes, and we're going to register a variable. Now, if you haven't done a whole lot of Ansible, registering a variable is how you let Ansible know this is important. Like normally Ansible would just run along and it would do this thing you told it to do and it would forget about it. The only thing it would carry forward from here would be whether or not on all the nodes that it hit it on, which by the way, this is just localhost, it would say, did I succeed or did I not? That's all it would care about. That's literally all Ansible does, is knock out tasks. Knock out tasks, you're okay, or you failed, or you were skipped, or you know, that's it. That's all Ansible does. But if you say register, what it'll do is okay. I'll throw that in my sack. I'll keep that with me going forward. And the name you give it, swappy, is how you call it later to debug it. So we're just going to hit that endpoint, say that the data is important, and then pull that data out. That's all we're doing in this lab. Super simple. Maybe the simplest of all things we could do, right? In fact, I've talked about it way more than I needed to. We could just run it and see what happens, right? Look at this. Here we go. By the way, this probably looks a lot like that page that we just looked at. You could even compare them if you wanted to. They're the same data. But what we've been able to do right here is, you know, we started it. We gathered facts on the machine. We pulled down swappy to get the results from the web page. Again, Ansible only really cares about whether a task fails or succeeds. And then we debug the variable. So swappy, which is the Star Wars API, is the start of our returned data. And it's JSON, so it's a hierarchy. It's swappy dot. And then we've got what is allowed. Now, if you don't do any API work, like if you're not like a front end or a back end developer, when you share out any type of content from a web server, you can always set up what people are allowed to do there. And typically, you'll then tell people what they're allowed to do. They can get, they can put, they can. There's a head. Head is this idea of pulling the information, and then options, right? So these are the things that people are allowed to do against this endpoint, right? There's, if it's changed false, well, in this case, nothing actually had to change, so change false because that module is always going to return that. And then the connection is closed, and here's the content in a raw JSON format, right? So we can do swappy.allow if we only wanted this information, swappy.change. Anyway, so we come down, right? Swappy dot, remember, because JSON is all called in a hierarchy. We have any of these values, but we can do swappy.json, and that will bring us down to here, right? So as we call it, right, in our hierarchy. And then if we wanted count, we could do swappy.json.count, and we would know that there are 82 returned values from this query we just made, right? Maybe that's important, like if you're hitting a satellite server and you want to know how many servers are in your inventory, because you want to compare the number of servers that you have registered with Red Hat with the number of servers that you think you have in your cluster. All of the data are string. No, some of them are treated as numbers, RNX. Some of these are numbers. Yep, they're not all strings. Some of these will be down here as actual numbers. Well, actually, I take that back. All of these data, as I look at them, are strings, because when you see a number and then the number has quotes around it, it's being treated as a string, even though it's a number. So that's not an integer right there. That is a string of 172. When you get it, you can turn it back into a number if you wanted to, right? And most programming languages nowadays will do that for you automatically for you, right? So real quick though, we're swappy.json.results. Whatever we want, right? And then now, well, hold on. Results is once we have one of these in JSON, now we've got these groupings of things. So all the way down to here is the first instance of results. Well, most programming languages start counting at 0, right? Most everything starts counting at 0. It's the first state of nature, is all zeros. So this is, if I wanted to hit it, swappy.json.results 0 would be the first entry. And then from that, I can say dot whatever I want. So let's, again, it's one of these things, we talk about it all day, but why don't we just go hit it? And I tell you guys all the time, like, when you first learn a technology, maybe you've never done this before, maybe you've never hit this, then you start to think, well, hey, I could talk about it all day, or we could just go hit the data and see what the different output are, right? See what the different data that comes out of this are. So this was us hitting this and seeing all the data that's there. Can we carve down? Can we go look at this root API? I'm going to go VI it real quick. And, oops, if I could type right. I'm going to come down here, and I'm going to just comment out all this noise. This was a lot. This was the whole thing. And I'm going to add back in this part right here, where we're going to go to swappy.json.results 0, like I just described, right? We're going to just go and see, can we see just that one result out of this? So escape : WQ, and we rerun the playbook. We see what kind of different output we get. Swappy.json.results 0 gives us this first person who was named Skywalker, and there's all of his information, right? And that is as far as, I think, as far as I went in this lab. Yeah, so this lab is just hitting it and pulling it out. And then here's some questions. What might you use the URI module for with an API? Well, I want to pull information out and give it to Ansible, and then have Ansible be able to do something with that data later, right? We pulled a bit of data. Is there anything else you would use it for? Yeah, so we're pulling out something that seems pretty, this isn't that important. But what if I needed to know, I just needed to know for some reason, the number of characters. And again, we come up here just a little bit. Well, look, again, this is all the raw data, so there's a lot to look through. Instead of json.results, we want json.count. And I say, can you tell me how many total characters it responded with? And you say, yeah, I think I could probably do that. I'll just change this to, from results here, to count, right? And count was down that hierarchy. We run this, and now Ansible's pulling, oh, there's the count. There were 82 total, whatever they were. Now, we only saw the first 10 because it was pageified, right? So there were individual pages. But now we have that little piece of data that we want. And I can't tell you all the ways that you may want to pull data over time, but I can tell you that you can do it with the JSON hierarchy. Is pretty easy to get working. You just go test it and pull your data out, and then debug whatever data you're looking at, right? And this is an iterative process that you can go through pretty quickly to get Ansible the information you need for whatever. Maybe you got to go pull. Well, we're going to do something here in a minute where we go do something like real. That's like a real use case of this in a minute here. But this lab, super simple, shows you how to hit an API, right? It's a Star Wars API. It literally means nothing. But I said, what is the hierarchy of data in JSON that you're interested in this output? Well, that is swappy.json. In that case, results. Yeah, RNX, nice. Yeah, and I tell people all the time, I support front end, back end. I build all the platforms out that stuff runs on. So I do quite a bit of, helping people with. I don't help a lot of people with this. I mostly show this to like my engineers. But this is a thing that's valuable, and I'm gonna show you how it's valuable here in a second for people that maybe go, that's like a little party trick. Like Scott just went like this and a little sparks shot out of his hand. It's like if any of you remember the X-Men from the 90s, there was this comic called X-Men. And look, I know everybody knows who X-Men are, but there was a version of it that we watched in the 90s as kids, the cartoon, and there was this character Jubilee, and she just went like this and shot like sparklers out of her hand. And the sparklers never did anything to anybody. They were absolutely like the most. I know she had more power in the comic, I get that, but I'm saying in the cartoon, she was absolutely a worthless character. She would just like go like this and shoot sparklers out of her hand, and you're like, oh my god, that's like that's like a more useless power than just like, I don't know, like being able to like, you can only move around office furniture or something. It was like this useless skill she had. Anyways, my point is, some of you might be looking at this and going, it's not that super useful. I get it. Let's make this more useful here in a second. I said, can you just get the returned number of results from this JSON? So yeah, so let's answer these questions here. What might you use the URI module for with an API? And our answer here is I can pull information from a web page or web resource. It doesn't have to be a web page, strictly speaking. It can just be data coming out, right? It says, what is the hierarchy of data in JSON that you are interested in this output? And in this case, we wanted so swappy.json.results, right? So let's and then it says, can you get the returned number of results? Hey, thanks for that. You know, you guys can use your Prime anywhere. You chose to use it here. I appreciate that. Hopefully that keeps you from having to see any kind of ads or anything. I know Twitch has ads that get inserted all the time. I think YouTube does too as well. Wait, hold on, Doc. I missed some stuff. But generally, host is our home lab as a basis for all Ansible commands. Yeah. Doc, we did host the other day, but as a quick rundown of like Ansible hosts, let me just show you real quick what a host file might look like. In my home lab, if I cat Etsy Ansible hosts, yeah, our host file is tremendously important because it's all of the devices that we can hit via groups. So I can use CentOS to hit all these boxes, CentOS 7, CentOS 8. My labs are these machines. Ubuntu is here. New servers that I had built out are here. And this was an inventory name that I might never use again, but it was when I first built stuff out. All Dungeons is this is inheriting all the children of red dungeons and blue dungeons. So here's the red dungeon nodes and the blue dungeon nodes. But if I want to hit all dungeons, I can use this host group, which just inherits those two groups, right? It's like a hierarchy that aggregates them up. So the question was about like Ansible host. Ansible host is probably one of the most important concepts to know because the inventory host you're hitting is absolutely critical to what different configurations that you're doing are. In this playbook, though, and the way we're doing this playbook, we're just doing local host and then going out and hitting an API because we just want to see data come back, right? We want to see what the data are going to show us, right? That kind of stuff. I said, can you get the number of a result from this JSON? And the answer is yes. We would just change that to swappy.json.results. So let's go look at maybe, let's look at the questions for this lab. Can you hit an API, any API out there in the world and debug the output? And I think we can do that. Yeah, I think we can figure that out. Let's go find some other API that's out there. Let's go to USGS and look at all of the earthquakes in the last day. Look at that. Here, boom. I'll link this to you guys that want to do this with me. Here you go. Yeah, URI is the name of the module, and URL tends to be what we think of things, Uniform Resource Locator, right? But now, look, I've got this query here. What if we just took that query and we went and dropped it into this playbook? So I just VI this playbook, and I go change my URI here. Just do like a $, I, and then I paste with right-click in this case. Well, Control-Shift-V will do it. And we just grab that, and then now we're going to change this to maybe geo, right? Maybe we call this geo. And then we want to debug everything to start. So we just go geo, and then here we'll, I guess I could have done it here, but let's take this, we'll just comment this one out. You guys will find that I like to do things very simply, and we're just registering the geo. Yeah, I don't know. Maybe we call this earthquakes. We'll call it geo because it's easy. But you can do anything you want. How can we add payload to request? I will show you how to do that in a second, RNX. There's another lab I'm going to do, and we're going to do a full checkout of variables and get tokens and stuff like that in a minute. Trust me, this is about to go, like I said, this other lab I'm about to do from here is the most complex lab I've put in Killer Coda. Although I think that most people will pick it up if they want to. Let's right quit, and let's run this API real quick. This is gonna blow up the screen because it's gonna be that other page. But we're gonna see the debugged output of what's coming out of there. So here's all this information. Oh, look at this. Here's all the earthquakes, right? So many earthquakes. In fact, maybe too many for me to even be able to see the head of this, right? Right? So here's this, but it's a hierarchy. So what I might need to do with this is I might need to actually one thing I could do with this, because there's too much there. It's scrolled off the top of the screen. I might have to throw that into a file. Right? This is admin stuff, but maybe I say geo dot text or something. It doesn't really matter. You don't have to put any extensions in Linux. Linux doesn't care. Linux doesn't give a damn about your extensions. Let's just call it geo.text for now, though. And I can grab this data. It's going to be scrubbed from color. That's fine. But now if I need to more temp geo, now I can see the top of the data. And the top of the data looks like this. It's geo dot whatever, right? And in this case, I can see all this stuff. Here's the access control max age. 86400 is, we said in the call. Where's it at? Hold on. Hold on. If we cat API call, I said now minus 1 day. But what was actually fed into the API call, the data that came back, is right here, 86400. So if you took that and you divided that by 24, and then you divided that, took that, you divided by 24, divide it by 60, then that's the number you would get for, that's the number of minutes, or seconds rather, in a day, right? Yeah, you divide it by 60 one more time. That's how many seconds there are in a day right there, right? 86400. That's also a useful number for a bunch of other things. But then I'm going to go down and here's my content. So geo.content. And then I can start to look at the information that's in here, right? And maybe this stuff's only kind of useful to me. And then, we can go all the way down to the end. Let's see. Do they have at the end? Sometimes at the end of these. So here's more data. All day. I'm holding spacebar to go page by page. Lots of data, right? Lots of information in here that I can pull and look at if I wanted to. Let's go all the way to the end. And all the way at the end, I got the status return code. Maybe I only care in this playbook that geo.status was a 200. Maybe that's all I care about. And some of you might say, well, I don't know what that is. All right. So there's web return codes, right? And, for people that are, developers and stuff, you deal with this all the time. For other types of engineers, you might not hit this a lot. But I can tell you, if you want to be in systems engineering, understanding your HTTP return codes is one of the most important things you can do. So you can find them on Wikipedia. You can also find all kinds of jokes about them out there in the world. But basically, you get informational as any of your 100s. Success is any of your 200s. That's what you almost always want to see. Any 200. 3 is a redirect, which means that in the future you're going to have to change the way things behave. 300s can be success or fails depending on what you want. But then the two big ones are 400 is my problem, 500 is the server's problem. However, as I'm the guy who almost always runs the server, right, because I do platform engineering and system, 500 is also my problem. But yeah, 404 is a not found, but it tends to be they're saying that the client, you, looked for a resource that's not there. That's what a 404 is, right? So anyways, they walk you through. There's a whole bunch of them. There's some really funny ones too. Like what's one There's one in the 500 range that's like it's a joke. There's unofficial codes. There's one that's like, this will never respond because this is a printer or something. There's all kinds of jokes over the years that you'll run into with these. Where's this one at? Oh, here it is. I'm a teapot. This is actually a real defined RFC. You can go look it up, 2324. But it's like, this will never respond to you because I'm a teapot, right? Anyways, there's a whole bunch of them. You can go look them up if you are so inclined. But at the end, we've got all this data down here. All this tasty data about, here's the URL I originally called, and then we've got when it was last modified and all this information. But somewhere in here, and I could have sworn it was at the top. Let's go look at it again. I could have sworn they had the total amount. So let's go down a little bit. This is all the raw data here before we get to the actual data. Hold on. We'll get to the end of the raw data here and we'll be able to see. Should be approximately halfway, but we'll see. All right, hold on. Right here. Going up. Ah, right here. And somewhere in here, we should have. So here's JSON. And there is, okay, so content failed false. I would have thought that they would have had. So that was content. This is JSON. Then there's features. And then we can start to see each of the different. So the features and each of the different events that have happened, and we can go pull information about that event out of this. All right. Yeah. Hey, Wusa and Bottleneck, thanks for showing up. We're just working on Ansible, right? It's Ansible. We're asking questions, and can we go pull information from this? Now, I thought there was one that added these all up. But I don't see that here. And I thought it was right at the top. Yeah, I don't see it. I definitely see that next part. Yeah, we could use JQ on this as well. Absolutely. We could throw this in a file and do JQ. JQ is a whole nother topic, but that helps us to parse out JSON, right? Problem is, we don't know exactly in there what we're looking for, but I guess we could use that, yeah, to find in the hierarchy. This doesn't count it for us, but there is a way. I have a way that I count this in some of my. I have Python that I use to normally do this, but I'm showing you guys how to do it in Ansible because I think it's useful. I thought we had. Hold on. That's our last one. Ah, there's our count. So it's under metadata. So metadata and then count right here. So we have the count of how many of these there are. So I should be able to find the hierarchy of that if I wanted to. If I started with geo, right? Geo, and then I go to .metadata, I should be able to get that information out. So let's go look at our API again. And it's geo. We don't want to dump everything anymore. So let's see if metadata is going to give us something more along the lines of what we want to see. And if this is small enough, we don't need to tee it out again. But let's see if this gives us geo dot, is it dot results? Geo dot, not content. Hold on. Let's go look down here. Geo.json. That was my bad, guys. I should have. Been a while since I've done this. It's geo dot, and then this is the JSON output, right? So then with this, we're going to run that, and now we'll see just the metadata, right? And here's the metadata. So now if I wanted The status code, again, if I just wanted to know that this website was up before I did whatever else I wanted to do, I could do that query, geo.json.metadata.status, and then for the rest of my playbook, if I wanted to only like send a debug message if geo.json.metadata.status is equal to 200, I could do that, right? This is one of these things where I'm not telling you again how to use it. I'm just showing you that you can use it. If I just wanted the count of all of the earthquakes in the last 24 hours, it's 207, according to this geological survey, right? That's the geological earthquakes.usgs.gov. They're published earthquakes. Now, fun fact about it, you don't have only earthquakes. See how this type right here is earthquakes? This also registers explosions that are big enough to generate earthquake-like results. So if you look through these, and you can go and you can parse out all the types and then have a count, make sure all the types equal 207 as well. You can count them up if you want, if you're one of these people who like to play with that data. And I would use Python for that. But this is a tool just, again, to show you how to do it in Ansible. We can pull that data out, get our count, and then we could just make sure that there were 207 earthquakes. Or we could just check for any types that aren't, earthquake. All right. So the point is we can do that. And the question here is, can you hit any API? Yes. And we did that with the US, this one here. Right, this is just one that we grabbed. And this is not obviously a lab on any of that stuff. This is a lab on using Ansible. So that's probably as far as we need to go on that part. All right. So let's go do something useful with this. This is again, you might look at that and go, oh, that's a nice little parlor trick. I agree. This is not super useful, but this is the start of something very useful. Hitting an API in your organization and knowing how many servers you have that morning registered to satellite, how many devices have called back for maybe their New Relic or their Datadog or their Falcon sensor, which is Falcon sensor is part of CrowdStrike maybe, and you want to know how many of your devices are doing whatever, you might just go hit an API and pull that information. So that's useful. There is a whole big effort that's kind of big in engineering circles, and some companies are trying to be it's an API first, right? And that's this kind of little, I don't know, I guess it's a DevOps thing where everything's an API. But do you guys know that that's been around since the 90s with Amazon? Like Amazon, back when they were just a bookseller online, the what's the name, whoever it is Bezos or whatever, he established that the company would communicate internally via APIs. So if you ever go look up like API first strategy, you almost always see Amazon mentioned first, because that's how that organization was built to communicate, right? I checked my package location and Notify sent it to my desktop. Nice. Code Llama to help you write a script. Nice. That's Smithy. I like the name Serious Business. We're all serious around here. So let's jump real quick from this part of the lab. I'm going to jump out and I'm going to give you guys a link to a different lab. And you might say, Scott, we were doing Ansible, but now you've got us over in HashiCorp. Hold on. Let's use Ansible to read secrets from a vault. So this is, again, I'm going to link this to you guys on the YouTube side that want to follow along, and I'll pin it for you guys over on the Twitch side. This is, again, the most complex lab I have. Like, I don't think I have anything that's more complex than this, but it's going to use all the same stuff we just did. Make this a little bigger so you guys can read it. And here's the question. Examine the workflow for the task that we're about to complete. You can right click on this and say open image in a new tab. And there is what we're going to do. We're going to set up Vault, which is a HashiCorp tool. We're going to, inside of there, we're going to use their tooling to create a secret. We're going to enable user pass authentication, and then we're going to create a user. These tasks are going to be done by other teams in the organization. Let's say, and we're building our own lab environment, so we're doing everything. Creating a secret is probably going to be your developers. Your developers are going to make a secret, and that secret's going to be something like the production or the test environment database password. They're going to put a secret in there. It's actually funny, like I'm wearing a black shirt, but it is getting picked up as color, so like you can see the letters there running through me. Anyways, then enabling user pass authentication is probably your security team that would do it. And then creating a user for yourself is also something that your security team would probably do. So there's different teams that would be involved with this in the enterprise. HashiCorp also has Terraform, yeah, RNX. We're not going to be using Terraform right now, though, but that is all API calls under the hood, too. Once we get this done, once we create this and make a secret and all that stuff, we are going to then, we're going to do a couple of other things in here that give permissions. I didn't draw them out because they weren't really important to the conversation, what we call not germane. And over here, Ansible then is going to send in a username and password. We're going to use this URI module. We're going to send in some information. Vault is going to respond back and give us a token. Then we're going to run around with that little token as our authenticator, right? It's an OAuth token, right? Like it's actually, well, it's going to be a what the hell do they call those JSON JWT, right? JSON web token or whatever. So we're going to have this little token, and we're going to give that token back in to prove that we're the Ansible user with the permissions we have to read the secret. Vault's going to verify that we have all those permissions, and it's going to send back whatever tasty secrets we want to get out of Vault. Some of this you're going to go, well, Scott, you just made it all. Why didn't you just put it into your playbook? Because in an enterprise, when we productionize things, when they become part of a pipeline, the secrets are being created by the developers or the whatever teams have access to that data. We, as, again, you might say, well, Scott, this isn't really platform engineering. This is DevOps stuff. I'll just tell you, I've had to do this a bunch, right? And maybe it's just because I'm the guy who knows how to do it, but I don't wear the title DevOps or SRE. I've just always been the systems guy, right? Like I've always been down there building the Linux servers. But this is something that I've had to build out and learn how to do and that kind of stuff because it happens. But this is part of like how a pipeline would work. So anyways, you can look at that all you want, right? You spend all day looking at that. But the question here then is, could we build it? Your team has determined they need Vault to test in their dev environment. HashiCorp Vault has been installed on the server. So I should have Vault like this. Boom. There's the Vault command. But I can't quite get to the server yet, and that's fine. And then it says to start the server in dev mode, export the required values to my shell, and verify that the server is running. So the first part of this is, there's some tip, for the information. And here's our solution. We're going to start the Vault in the background. Boom. It's in the background, of this shell. And then I'm going to export some values. I'm going to export to tell my server, hey, when you try to talk to Vault, you're going to do it locally. This is a variable, right? We're exporting Vault 127.0.0.1 on port 8200. That's local. But then I need this Vault token, right? This Vault token right here. And I always tell people, don't just copy this and then hit enter and wonder why it doesn't work. Read what it says. There's a token from the output right here. If I want my shell right here, my user that I am, I happen to be the root user on this box, to go and talk to Vault as though it's the root user, I need this root token right here. Let's paste that in right there and hit enter. That's the first part of the lab. Now I can do Vault commands against that server. I can say Vault status. I can see that we are not sealed, so the Vault is open, meaning I can go ask questions to Vault. If the Vault is sealed, you can't ask questions to it. And you can't get it to go give you information from the back, basically. Kind of like if a shop is closed up, you can't go to it and ask questions, right? You can't go talk. And then we'll go check. Let's just make sure that Vault is open. Yep, 8200 and 8201. So the system's listening. We can hit check and we're done with that part. That's just some setup stuff. Again, we're just standing up Vault. So it says now you have Vault running and you need to create a secret. You will be reading this secret from another tool, which is Ansible. And in a real environment, it could be populated by any process or team. So somebody's setting this up. So we're going to create a username and password for the application to read. And then we're going to verify that the username and password's been set. You know, hold on. I need to do one thing real quick. I'm going to go back here. I'm going to reopen that in a new tab just so we have it. Because when we're done, we're going to want to come back and look at this. Also, hold on. I don't know what's going on here. The music's both too loud and too distracting. All right. I just had, that song was just really going hard. All right, so we go forward. Here's our solution, and it says, let's say vault secret list detailed. This is hard to read on this screen, I get it. But basically what it's saying is there's a key value version 2 of KV. So KV is what we're going to be using. And we're going to put a secret. We're going to pretend that we're that dev team. And we're going to put a secret out there. And it's going to be at the path data app1 values. And the secret that we put in there is username equals secret and password equals super secure. There we go. I don't know why this warning's coming up, but we're not going to worry about it as long as the lab works. Then I can go and I can pull that secret back by reading that value and see that the password is super secure and the username is secret user. All right. So because we've got a root token here at the command line, we can pull that information. Good. So we hit check and we've created that part of the lab. We've done this. We've turned on Vault. We've created a secret as though we're some other team, right? Now we have to create a programmatic access to access that secret. We're going to use username and password. So that's user pass authentication. Then right here, we're going to enable user pass authentication. We're going to create the Ansible user to be able to access Vault. And we're going to give that user a password. And then we're going to make a policy so that that Ansible user can read that path right there. Data app1 values. Well, it's secret app1 values, right? So let's go through this and say, let's enable auth user pass. So we turn that on. We're going to create a user and give them a password. And the password is just going to be Ansible 12shift34, right? That's what we're giving it. And then we're going to make this little file. And this file is just going to be something simple. It's going to be path secret and anything after secret. So anything in this path secret is going to be able to be created, read, updated, deleted, listed, and patched by whatever user gets this policy, this Ansible policy. So let's write the policy into the system, and then let's write that policy to that user, and then let's read that user and verify that that user, right here, read auth user pass users Ansible, has that policy. So I know that's outside the scope of this, but we have to do that to get to the next part. So again, this is why I say this is one of our more complex labs. You did all those pieces, right? You can go review what we did here and here. And then when we go look at it here, what we've done now is we've enabled user pass authentication. We've created a user called Ansible. We've given them a policy, and that policy says that they can read that path to that secret. So those are the things that I didn't put them here, but that's essentially what's happened. So now we've built that, and that's again, that's on the HashiCorp Vault side. So for the lab, we just have to hit the buttons and do it. But I wanted to explain what we're doing. So we're ready to go. So it says everything in Vault is set up. So now you have to use Ansible to pull the information. Remember when we started this, we were using Ansible to hit an API. Now we're going to use Ansible to go hit that API, log in as a user, the Ansible user that has a password. It's going to get a token back. It's going to take that token, it's going to read the secret, and now it's going to have the secret to use and put into the deployment, go through a pipeline, whatever you're doing further on, right? This is, again, we do individual pieces, and we ask ourselves about these individual pieces so that we can, verify that we understand things, right? That's what the Socratic method is. So anyway, so we cannot leave our passwords in Ansible out in the open, so we'll be using an Ansible Vault. Yeah, I added this little security thing. Ansible Vault is different than HashiCorp Vault, so now you're using two vaults. I know. Create a playbook that uses a username and password to get a Vault token. Good. Secure your username and password in an Ansible Vault file, and then modify your playbook to feed that data in and get the value back, right, of secret app1 values. At the end of the day, some team came in and built this information and put it into a vault, and we want to read that information so that we can use it in our playbook in whatever way. In this case, it's a simple username and password, but it could be a database connect string. It could be a internal maybe API that only exists during this deployment. Like, it can be whatever we want. It's just something we don't want out there in a Teams message or in an email or something floating around. This is a secure way, and organizations use Vault for this. It is a secure way to go check it out with some other tool or process. All right, so this is where we're at, guys. This is what we're doing here. Here's our solution. So we'll install Ansible real quick. Make sure Ansible's on the system. And I have a basic little playbook. I believe this one's already made. Let's check. If it's not made, we'll just copy it in and make it. But I think I already have it in the lab for you. But it says make a playbook that can authenticate to Vault. So let's do this real quick. So clear. Oops. We don't have any answers. Okay, well, we're going to have to make it ourselves. So vi root secret read.yaml. And you can spell YAML with a YAML or YML. It doesn't matter. It doesn't matter to anything. And here is a quick Ansible playbook. This looks just like what we did earlier. It's 3 dashes, read variables from localhost. All this stuff up here is the same. But down here, we say test my connection to Vault for credentials. There's a URI module. And the URL we're using is the localhost 127.0.0.1 on port 8200. And we're going to go to v1 auth user pass with a login for a username. Now our user from just a few seconds ago is Ansible. So we got the Ansible user. We want to return content. Yes, method is going to be post because we're posting. Body format's going to be JSON. And in the body, we're going to pass a password. So this password is going to be passed to the system. And we're going to register out everything it gives us. And then we're going to debug everything to the screen just so we can see it, right? Same thing we've done in the other labs. So let's run this playbook real quick, and it's going to break. Says it right here. Oh, nope, it didn't break. When we ran it, here's why it didn't break, is because at the command line, I gave a username and a password for Ansible to be able to access Vault. And right here, it went to user connect. It connected. And it returned us back this client token. This client token is very important. So we got a JSON.auth.client token is this token right here. That token then can be used by a service or a user to access the API, if we need to access the API, and pull data out, right? So we've got that. It all came back good. So we've done the first part of this, which is to go and check out, as it were, our credentials and get this little client token. So now we need to use that. But before we use that, we're gonna add a variable. We're gonna do something that's a little off. We're going off to the side, and we're gonna do an Ansible Vault create. And in here, I'm just gonna make a password Ansible 1234 and Ansible 1234. And then in here, I'm just gonna add those variables so they're no longer passed at the command line. I don't want to see them at the command line anymore. So they're just going to be in this vault. And now if you cat vault, you can't read it because it's AES 256 encrypted. So that's the minimum standard for internet security, right? And then now we're going to add some lines to our playbook to make this a little more usable. We're going to add the line vars files. And then in here for the vars files, we're going to say root vault.yaml. So we're going to use that vault. And then that's fine. That's all we need, right? And again, I said this was one of the more complex labs. We started with one of the simplest labs I have. Just go hit an API. And then now we're going and we're using Ansible to read from Vault and pull information and stuff, right? So now we can run this again, but without the variables at the command line. And now you need to know that other password. So Ansible, whoops, 1234. And now this will go read, and it'll do that same thing. It's giving us a client token that we can then use. By the way, that client token is good for, by default, I believe, 31 days. Yeah, here's the time right here. But if I were to go to this real quick, and I just take that number, right, and divide it by, let's divide that by, hold on, how many, let's go 60 times 60 times, oops, 60 times 60 times 24. And that gave us our 86,400, right? Remember we talked about that earlier. But now we take this value here and we divide it by 86,400, right? And that'll tell us it's oh, wow. So that's funny. This is that's the max age is 365. Where's the actual age? That's my bad. Ah, here's the lease duration. I'm messing up. So here's the lease. How long is this lasting for? So we do that same thing again. Whoops. Where are we at here? Lease duration. Boom. Hold on. Oh, there it is. Okay. And then we divide that by the, what was it? The 86,400. I think it's 32 days. So 32 days right there. That you guys see where I'm getting at? How long is this client token good for? I have a talk that I gave to the, there's a Kubernetes group out here in Phoenix, and I gave this talk a while back. And when I did, I was showing them that you don't leave the leases at 32. When you want short-lived credentials, 32 days is not a short-lived credential. That's a long time for something to be compromised. That's a long time for access to be held open. Most of the stuff, when I do cloud stuff, I set this lease duration down to 10 minutes. Because, hold on, if you're going to go check out a resource and then do something in a pipeline, do you really ever need more than 10 minutes to access your resources and build with Terraform or build with Ansible or whatever you're doing? The answer to that's no. This is a default. So, you know, again, this is one of these things where, you know, we're not doing Vault right now, but if you go take your Vault cert, you need to know how to change your lease durations. So I'm not going to change that in this lab though, but we are going to move forward with the lab, and we're going to go into the secret read. I'm going to go ahead and comment. I'm going to comment this out because I don't want to see. Well, we'll leave it in. We can leave that in. That debug can still happen. So now we're going to add a little more. And right here, oops. Control Shift V. Whoops. Always fun trying to get our stuff to Control Shift V. There we go. All right. So now check this out. What's going to happen next? We've got our user connect where we get that token. Then we're going to go and read the secret. And we're going to try to go hit that secret. And as we do, we're going to say the method is get. We're going to return the content yes. And then we have to give inside a vault this header. And the special value for the header is xvault token. And we're going to hand in that token that we just had. We first authenticated with the username and password that we are the Ansible user. And that is a process of authentication. When we get that token has attached to it authorization, right? We know we are who we say we are, and now it knows we are who we say we are. And now we got this token that's authorized to read that value that was put in there earlier by some other team. Well, we did it for the lab, but let's say it was the dev web team, you know, and they were giving us some connection back to some database they have or something. But I never want to know that crap. I just want it as part of my pipeline. I literally do not want people to send me shit in Teams and have passwords. Nope. Also, tools like Vault and if you get up into cloud and you do like the tools like the Secrets Manager, it can rotate passwords for you. So when I go check out the password, I have whatever the default generated password is for those few hours or for that week or whatever, and then it's rotating my passwords all for me throughout the organization. So there's a lot of uses for this. We're just doing one, but we're going to hand in that token. That right there is the same value that comes from the user connect earlier. It's a token. And then we're going to see, could we read the secret credentials? Right? We put them in Vault. Now we've given a user access to do the things. Now we're going and reading it, and we're seeing if we can get it all to come out. So let's run it. Vault password is Ansible 1234, and it's going to go and it's going to read. It's going to do that first one and generate another one of these. So we got a few of these client tokens hanging out, by the way. I think we're up to 3 now, right? And they're good for 32 days or whatever. But then we come down here. And now we're debugging the secret creds. We went back to it and gave it that token. Now the JSON.data.password and username are right there. There we go. Verify that you can read the data. If you want to, you can add this little bit at the end where we were just debugging all the secret creds, but if you just want to see the individual debugs, you can go right here, and it's literally just the same hierarchy we've been talking about this whole time. secretcreds.json.data.data.username and secret_creds.json.data.data.password. It's right there, escape::WQ, and we can run it. And now we can go pull those pieces of information. Oh, well, I'm going to do this. In a, you see me put the password in each time for Vault. That gets bypassed in the organization by tools like Tower or Ansible Automation Platform, where we can set the secret credentials in there and you don't have to do it anymore. You just get permissions from your login to the tool or whatever. But there we go. Username, secret user. Super secure. So, would we normally print this to screen? Oh God, no, right? Like that's not what this would do. This, I'm just showing you the way a pipeline would work in an organization. So if we step back to here again, this is all the things that we did. Created our secret. Well, we turned on Vault. Then we created a secret. We enabled user pass authentication and created a user. Again, those are probably not functions I'm going to do. That's going to be somebody in the team, like some security over here. This is our dev team over here. And then, but I build the Ansible process that can go read that information out. Send in the username and password, get back a token. Send in the token, read the secret. Take the secret and go use that in a pipeline, part of my playbook that has the authentication, and has the ability to, maybe I'm building resources and then I'm setting that in as an environmental variable in Kubernetes or something. Look, there's other ways to do it with Kubernetes. We can just read secrets out and stuff, but the point is you've got all these things that you can do, right? All right. That is, again, like I think the most complex, lab that I have as far as, people, some people want the more complex stuff. Some people want it easy. This is, this is like foundational to like what people call DevOps nowadays and building pipelines of stuff and all that. So anyways, there we go. That is pulling APIs. We did all kinds of API stuff. So it's what we're an hour in, and we've just done API stuff this whole time. We did one lab. We only got through one lab for all of it. Well, we did 2 labs now. Then you hit check, and it says, "Look at you. You set up Vault. You put secrets into it, and then you programmatically pulled them out via Ansible." So that's a kind of useful thing. So can we hit any API? Yes. We hit the Star Wars API, which is Swappy. We hit the U.S. Geological Survey one and just got this just a crushed amount of data. And then we got very precise data from other people in our organization, and we read out the exact secrets that we needed to do whatever in the organization, right? Heather, yeah, this one I've done this one before, but this lab looks very straightforward. But this lab is like an archetype for all kinds of stuff that happens inside of organizations, right? All right, so that's a HashiCorp lab, but it's really Ansible under the hood. Okay, so what's our next one? This one says Ansible Vault and Variables. So let's go link this one, Ansible Vault and Variables. So this one jumps into some of the topics that you guys were going to see. So I'm going to link this on this side, and then I'm going to pin it over on the Twitch side. Heather, you like the complex stuff? Good. Yeah, this is... I know a lot of times here I'll just be doing, base Linux and super simple stuff. Like the last few days, I've been kind of just fumbling and bumbling around in my home lab, and people are probably like, oh yeah, this stuff that he does is all like super simple. And I finally built this stuff all out, and the lab's up, guys. If you guys didn't know, I got everything working yesterday in here. I think I might have even been on stream, but I got these 3 nodes up. They have multiple disks on them, and then I'm starting to put the lab together. Maybe I'll even get the lab out later today, depending on I've got some work stuff to prep for, and I got college stuff to prep for. Maybe I won't get it done today, but the point is I've got a lot of stuff that we've finished the last few days. But anyways, let's do this next part of the lab. We'll stick to Ansible because that's simple. Well, or that's I don't have to think as hard here. It says here, playbook execution to see extra vars. Your team has decided they need to more securely keep their secret information. This happens, right? A team at some point gets asked by security, hey, what are you guys doing to be more secure or whatever? And then, your team realizes that all your stuff is bad practice and you got to do whatever. So instead of just passing values at a command line, you know that Ansible Vault can help be used to securely store our variables. So let's go look at cat root hosts. Here's our host file. Super simple. And then let's look at this variables YAML that we put together. And this is a super simple little, this is like the simplest little playbook ever, where it's just going to run against localhost, and all it's going to do is try to debug a message. And we're using something that hasn't been used before. You know what? I need to fix this lab. I've been meaning to do this for a while. I'm going to fix it right now on stream. I've been meaning to fix this one for a while. I'm going to call out what we're fixing, though. Hold on. This has been bugging me. This bugged me the last few times I pulled this lab up and I haven't fixed it. Vaulting passwords. Step 1. Actually, it's in assets here. Vault variables right here. We're using with items. The modern way of doing this is just loop. You can just use loop. And I'll prove that here in a second. Let's take that and then okay. So let's run through and run this playbook and see how this part of this kind of works, right? So we look at all that. Let's run this playbook, and this is going to break all over the screen. But why did this break? Well, it tells us right there, username is undefined. Right here, we're trying to call, we're looping over username and password as variables, and we're trying to put them here in items. So item in the first iteration of this loop will be the username variable, and the second time it'll be the password variable, right? But those don't exist because we didn't give it to them. So what we're going to do is something that we're trying to avoid by this lab, which is we're going to put the username and password at the command line as extra variables. Look at that. Username Scott, password secure. Anybody that comes along that has root access in this environment can press up or history or whatever and see, get out of here. And they can see that I put in a username and password, and maybe they shouldn't have that. I mean, look, if somebody's compromised your root account, you've already got other problems. But the point is, you still shouldn't, best practice, be putting usernames and passwords at the command line. This is not the type of things that we do as systems engineers and whatever. We don't just drop stuff in there. So how can I get these variables that maybe I need securely into the system? How can I do that? And the answer to that is you've got this tool inside of Ansible called Vault. The thing we're going to do when we create this vault here is this is like an exercise. This is almost like if any of you have done any computer science stuff, the first thing they have you do is build like a script from top to bottom where maybe you call variables and you do some stuff, and it's like super simple stuff. But one of the things then they immediately tell you is, well, but that's not how we do it. You're just touching all the individual pieces. Well, that's kind of what I'm showing you here. You normally wouldn't call Ansible with a vault directly anymore. You would use some other tool to handle it. But this is still a piece that's still there for you to use. So we got Ansible Vault create, and I'm going to give this password 1234. It's going to be super simple password 1234. And now I've got this encrypted, it opens up my editor, which is VI. And I've got this encrypted area where I can then go drop. In this case, I'm going to drop YAML format. And these are YAML variable formats. Oops. Hopefully I can do the whole damn thing. And we'll paste that in. And we've got username as user1 and password as some strong password. Right? And now if I cat vault.yaml, I can't read it. Right? It's AES encrypted. I can't read it. If I want to view it, I say Ansible vault view vault.yaml, right? And then I need to know the password. And when I do, now I can read those variables. All right. So this is a better way if you were going to hand data in than doing it at the command line, right? So now we're going to run this vault variables playbook Oh, you know what? Hold on. I gotta step back for a second here. Remember I told you this isn't the way we would do it? Let me prove to you that with items is not the best way. With items is fine, it still works, but it's loop now, which is a more clear what's happening. So let's rerun that real quick. I want to make sure that that works. Still works with loop, right? Okay, good. So now we're going to run the vault variables YAML and see that run against the vault variables. So let's go look at that playbook real quick. Cat root vault variables. And this one is going to say, I'm going to use a variable file. Give me variables out of vault.yaml. And those variables are going to come down in here, and they're going to read through and loop through, right? By the way, we got to go fix that. Asset vault variables. This is loop, and variables is also going to be loop. That's a more modern way of doing this. All right, Control S to save, and then I can come over here and say fixed loop in lab 10, right? Whatever. Commit that up, sync it. So now we have a commit to my Git. If anybody's ever doing these labs and you get stuck for some reason, you can always go look at the Git page for it. I have that available for anybody that wants to see how you build these labs. All this stuff that I keep over here, all of everything inside of, you know, all the labs are out there on Git. So if you guys need my GitHub, just let me know. But we're going to run, and we're going to ask at the command line for the vault password. And if we know the password, 1234, then it'll run and it'll do the things we want. User 1 and some strong password. And then now we can echo our password, 1234. This is also now, again, not very secure, into .pass file. And then we can chmod 400 .pass file. So now it's only readable. Whoops. Pass file. And if we ls-l .pass file, we've now got a hidden file that's only readable by the root user. Again, if root's been compromised in your environment, you've got way worse problems than this. But now we've got that. And now there's this other way to call this where we can just tell Vault to use a password file and it doesn't have to ask me anymore. Now it's using that pass file to open the Vault, and then the Vault is reading the variables and the variables are coming out. So this might seem like some simple stuff, and it kind of is. The steps themselves are very simple. But this is very important for how we lock up variables and then how we access them. I did this lab to show you guys, or I put this lab together to show you guys kind of the basics of the vaulting, even though this isn't really the way that we tend to do it anymore. What we tend to do nowadays is you get your Ansible AWX or whatever, your tool. You come into your AWX or Tower instance or Ansible automation platform, right? And then you've got these credentials in here. And I can set credentials up for you and you and you to come in and do these different things in my environment. Look, here's a bunch of different credentials that I have. I can get to my GitHub private. I have a local, GitHub, that's my private one that can go out and pull things out of GitHub out in the world. GitLab is my internal one, right? So I can call stuff from my internal, because I have stuff that I push up internally to my local GitLab that nobody else sees. I mean, I post them on Discord if people need them, but this isn't stuff that like goes out to the world, right? Stuff that's internal for my lab. And then other stuff, root, if I have root password can be a password just to get into individual machines. And there's all kinds of different types, but this tends to be where these things are. And then I can give access, look at this, I can give access to, let's say, the root password. I can go in here and I could give like some subset of users permissions to use this only on certain servers that I give them access to. So now, let's say I need to make, where's it at? Heather's over here, right, on YouTube. Maybe Heather needs access to like 5 of my servers, but they're dev servers for her team. With dev servers, a lot of the time, one, I can just deploy dev servers quickly, wipe them, start over. Maybe I want to give Heather the ability to push buttons and deploy stuff on their servers without having to come to me and ask my help. Or maybe I've written this deployment code for them and I can give just them just these permissions on just those 5 machines. That's what we call like role-based access control and attribute-based access control and all these other, because it's role-based access control because their role follows into whatever that is. But then attribute-based access control because it's like a dev environment instead of prod. I don't give people that kind of access on prod. Fuck that. I'm the one responsible. Like I tell you guys all the time, like as especially systems engineers, one of the only things I care about when we talk about KPIs, key performance indicators, I care about uptime of systems. When you go to make the server do something, does the server do that thing? That is almost the only thing I've ever cared about my whole career. In some ways, it's a simple life, right? Like I'm just some guy out fishing, and then you're like, are the servers up? And I'm like, yep, servers are up. That's almost the only thing I care about. And I know that kind of seems like I just distilled my whole career down. It's like I'm going to have like an existential crisis or something. But no, it's true. I really only care if the server's responding, if the service is doing the thing. Well, I don't even know where I was going with that. But anyways, is AWX installed on a container? In my environment, Sean Alvarado, yeah, my AWX is on a container. All right, hold on. Look, the guys get on me all the time, like the people in Prolog. They make fun of me all the damn time for how old my lab stuff is. Let's go do something fun real quick. Let's go to AWX on GitHub, right? Just AWX GitHub. What? You guys are gonna fucking make fun of me. Well, everybody makes fun of me. But anyways, AWX. Hold on. Let's go to the AWX install guide. AWX installer, right? Starting in version 18, AWX operator is the preferred way. So you come down here and you say, okay, AWX operator to build AWX. What's the most recent version? Well, we got release 2.19. I don't know where the 2 comes from. Because we're way past, we were up in the 20s. Hold on, hold on. We've moved far afield. Hold on. Let's go back to AWX. What version of AWX are we on? Somebody help me out here. Yeah, Ansible Automation Platform is what most people are using. If you're paying for it, you're using Ansible Automation Platform. You can still use AWX as an upstream right now. But hold on, I want to find... So, well, 24... Let's go look at releases for AWX. All releases. Here we go. Sorry, guys. 24. Okay, so 24.6.1 is up. 24.6.0. I could have sworn we had newer versions, but apparently we're on 24 of AWX, right? Yeah, that sounds... I guess that's good enough. Yeah. All right, 24.6, right? Does everybody agree? Then we come over... Oh, you guys are going to make fun of me. We are on AWX version 9.3. I am running AWX from like years and years ago. Okay. I missed your block monster. I don't know what language that is. I can't answer that block monster. So if it's not in English, unfortunately, I can't help you. Saigama, you said, doesn't matter what cloud we learn on, AWS, GCP, or Azure. Saigama, I don't think the cloud that you learn on matters that much, but I would posit the Professional Linux Users Group has leaned heavily into AWS just because we have a lot of AWS people around, and most of us have gotten some type of AWS cert, right? So I can help most, like in the AWS space. I'm a Solutions Architect Pro. A few other people in our Discord are also Solutions Architect Pros. So we can help you the most in that space if you are going there. However, I do have Azure, like an AZ900, so I could kind of start you out there a little bit. And some of our guys are GCP pros. But it does matter based on the... so the question was, like, which one of the clouds should you learn if you're going to learn the cloud? And I would tell you, find out, like, what you want to do and what industry maybe you're looking at. Maybe go do some stuff on DICE. And then say, okay, I'm on I'm on this older version, or I'm sorry, I'm trying to take my career this certain way. And you know, this person, I really want to go work for Lockheed Martin or something, and they use mostly AWS, let's say. So then you go and study that. That would be my kind of idea. Like find what you're interested in doing and then do that. Also, maybe find where you can do projects. I think AWS has some of the best project stuff, but that's just me. There's like some really good tools out there for learning that. Yeah, I'm on 9.3. But oh, somebody asked about whether that's yeah, look, this is containerized. Watch. So you jump over here, SSH AWX. So that's my tower instance, right? Docker PS. There's my it's Ansible AWX task and web, and man, they used to use RabbitMQ back in the day. I haven't used RabbitMQ for a long time. But yeah, there's my version of AWX. Oh, and they use Memcache Alpine. Yeah, like 4 years. That's probably closer to 5 years ago. And then they got Postgres running. That's their backend database for my home lab environment. All right, so you know, not a great security posture look, but it's fine. That's my AWX tower stuff. All right, so we were doing lab stuff. We pushed that up. I showed you guys that we have that. We did all this, and then the questions start. So we're doing the Socratic method. We answered all this. We checked this, and it said, "Look at you learning Ansible. You vaulted information and decrypted it to read variables. You solved this challenge." But now let's ask ourselves questions. Let's go through and say, what is the syntax for a variable in Ansible, and how do you loop over variables? So what is the syntax for a variable in Ansible? And for us to figure that out, we need to come in here and look at the variables. So what is our syntax for calling a variable inside of Ansible? It is simply two curly brackets, right? Two curly brackets. That's some name. There's a variable. There's a variable. Here's a variable that calls those variables, right? Well, calls the values out of those variables, right? And then you say, how do you loop over? How do you loop over variables or anything in Ansible? And the answer to that is we use the loop control. And there's a whole bunch of things. There's a whole bunch of stuff that we can do inside of loop. The with items is the older way of doing it. We say Ansible loop controls, right? And loops still gives a nod back, especially if you go up here and go back to 2.9, which is what we're on. Oh, look, they don't even have it anymore because it just stays at latest. That's fine. We'll just go back. There we go. Loops in the Ansible. Here we go. And when you come down here, they still give a nod to with items. So this is the way we used to do it. We used to do with items. And then we had with list and with items and with dict, which is dictionaries, and with, I wouldn't say dict. D-I-C-T. This thing won't swear, in case you guys didn't know. With flatten, so you can flatten out. There's all these things you used to be able to do, but they've moved away from it. They give like a nod to it, and then they say, we don't really do this anymore. We used to say with list, with items, with whatever. I'm going to link that right there so people have it in their notes when they come back and do the notes. But nowadays, it's like you can do a loop with until, and if an item's not greater than 2, you have all these control structures. You can count over a loop, all that stuff. Malvi said, how many hours did you spend time on computer daily while learning DevOps stuff? Well, Malvi, I was forced into DevOps stuff because I was already the platform engineering lead at, well, I was at AAA at the time. And I was their platform lead doing all the Linux stuff. And just, there was more work than we had team. You know, we didn't have enough team to do all the work. So a lot of times you have to do things more efficiently. So a lot of this stuff I learned out in the wild, right? And I've been using Ansible since, I've told you guys, I've been using Ansible since 2013. But I was using that for a very specific use case back with government projects, back when you weren't allowed to push keys places. You had to use your password everywhere, and I would use Ansible for that. That's actually how I got into using it. just to loop over a list of items. But oh, once you're using a loop, you've got all these things that you can use inside of the loop. All these pieces of control. So there's that. All right. Hopefully I don't have anything that's I've missed. But yeah, people on the YouTube side, I'm not trying to ignore you guys. But yeah, Natasha said real world content, love it. Yeah, hopefully this stuff's useful to you guys. We just do labs on Sundays. That's all we do around here. Yeah, you couldn't push SSH keys in government systems, in the systems I was on. So you had to use a password as a user every time. So Ansible can do that for you. I had like back then I had it was a Fed cloud environment, and I had somewhere around, I think I had like 700 and something servers. They weren't clustered, they were individual servers, but they all had same basic functionality of needing to be updated and patched and different stuff. And then some of them belonged to, there were different states. It was funny. It was a federal project, but it was at the state level. Yeah, I've talked about what I used to do over there, but that was a company called CGI, which is a Canadian company that runs a lot of government stuff in the U.S. How do we pass in variables at the command line in Ansible? And then why is it not a good practice? So how do we pass in variables at the command line in Ansible? And that is the extra vars, and then variable name equals variable value, right? And if you need to see that, it looks like this right here. When we ran it, that's how I passed in extra variables at the command line. So when you pass in variables, there's a precedence order. You do not need to know this. Like this isn't, nobody's ever going to ask you this on a question or a test. But there are 22 ways in precedence that Ansible can get things. And you might say, Scott, do you know all 22? Oh, hell no, I don't know all 22 of them. But I know where to find it. Variable precedence in Ansible. They've got using variables. And then you drop down right here to variable precedence. And they explain to you that from 1 to 22, the highest precedence, the thing that always wins, is what you hand in at the command line. You can also, instead of use extra vars, you can use a -e. But yeah, here's all of your Ansible variables, right? All that variable stuff. All right. So, you don't need to memorize those or whatever, but they're there, right? It's a thing to know. And then I say, why can't you read the vault YAML with cat? So why can't you just cat out root vault.yaml? Because it's, so why can't you just read that and it's encrypted and it says what's the standard, and it is AES 256. That's the encryption standard. It says it right there, but it's also just the standard for Vault. Also, I think I've mentioned this all the time. If you ever take like a certified cloud security professional from ISC Squared, or if you ever take like your AWS security cert, which I have both of those, this is the minimum standard for security in the cloud, is AES 256. So, all right, boom, there you go. How can you access the vault? Why might this be useful for pipelines? By the way, we did the pipeline thing already, so we know you can access the vault either in a interactive mode where you ask it for the password like this, and then you need to know 1, 2, 3, 4, or you can ask it with a right here with a pass file. So it says right here, how can you access the vault? You can use ask. I always forget the order of this one. Yeah, you can use ask vault pass, or you can use vault password file like this. And then whatever the file is, right? So those are the ways that you can do that. And then when running the playbook with Vault, what are your 2 options for giving the Vault password? Oh, this is that same thing. What your 2 options? I think that these are. I think I'm asking 2 different questions here. The right answer for accessing the Vault actually is Ansible Vault view or edit vault.yaml, right? And then I need to know the password, and then I can view the vault in an unencrypted fashion, or I can do edit, right? Drop me in my favorite shell, escape :q, no changes, doesn't have to save anything, and there we go. All right. So I think we beat that lab to death. Oh, I almost dropped my, almost spilled my soda there, or my Monster. But we're at an hour and a half, by the way, so we're doing all right. We've only gotten through 2 labs though. No, 3 labs now. We've done 3 labs, so probably take a break here in a second. Let's check on Ranger Dog. How's Ranger doing? Oh yeah, Ranger's nice and tired because he was just outside with the wife. So she was outside. I don't know how they do it. Let's see what the temperature is in Phoenix already. It's already 102 right now. It's only 7:54 in the morning. It's already 102. Isn't that wonderful? A wonderful day outside. Hey, Robdom, how's it going? Also, are you on both sides of things? Yeah. We are going through labs, Robodom. Robodom's one of my moderators, if you guys don't know him. He's very useful for you guys to ask questions to and that kind of stuff as well, especially down in Discord. And he's getting ready for Sec Plus, so we've been doing Security Plus stuff. Let's go do another lab. Oh, look at Ranger Dog down there. Let's go do another lab. Pull this out from YouTube because I'm on my cell or your call job and they block Twitch for some reason. Yeah, that's fair, Robodom. I could see blocking stuff like that at work. That's fair. Let's go look at pushing a message of the day server, message to all servers. This is actually, it's funny, there's actual requirements on STIGs, which are your Secure Technical Implementation Guidelines. There are actual requirements around having messages of the day on servers. So, this one says, let's go down here. We'll start the lab up. Did I link this to you guys? I did not. So here's the lab for people on the YouTube side. And then here's it on the Twitch side. And again, just hop in the lab if you guys want. They're free. They don't cost you anything. You could literally just push the buttons and watch what happens if you want. But it says right here, your team has had mistakes because users don't know what server they've jumped into, specifically dev or prod environments. And we could just go full stop right there. Anybody that's ever worked with users know that that's the case. Most of you that have worked with admins also know that's the case. People just mess up. People mess up all the damn time. So we're just going to give them a real big message of the day, MOTD, on the servers to help them know what server they're on. Hey, dummy, you just jumped into this. Whatever. Hey, you just did whatever. So let's check our root host file. Got that. And for the first time in all the labs up to this point, we've got these new little things sitting here. These are variables. In an INI inventory file, this is how you can assign variables to different hosts if you want to. There's other ways to do it. There's other ways to blanket and all kinds of stuff. But this is a simple way to add an environment variable. So it's key value pair. This is a variable called environment, and it is assigned to the control plane node. And this is environment dev, and it's set to node 1. In our simple little lab, that's good enough. You can have, here's an important thing to know. When you add a tag, as it were, this is like a tag, but it's a variable assigned to the host. You do not have, like if I have environment prod here, I do not need environment dev on all the rest of my nodes. They could just not have the tag. So there's different logical things that can happen here based on kind of where we're at. All right. So, oh, by the way, let me do this real quick for people. Discord on the Twitch side, and I'll go link the Discord on the YouTube side for people that are interested in kind of getting more involved with the group. Colorman said, hey Tanis, for just curiosity, how long does it take for dev to learn Ansible? I know there's no stop in terms of learning, but you know, just prediction. Colorman, I would tell you it depends on what you're doing with it. If you just go through, you know, the labs, I have 20 something labs on Ansible. I think you would. I think you would understand the structure of it. But I'm a big fan of finding out. Find something that you need to do with it, and then go do that, and that will, I think, help you learn more. Kind of like people talk about like project based learning. In engineering, a lot of times we'll call that scratching your own itch. Like I need to do this thing this certain way, and I know I saw that guy use that tool, and then you figure it out, or you go, look up somebody that had done something similar, and then you do a similar type of project. But I would say you could learn Ansible in, depending on your level of study, and under a couple weeks probably. Um, I would argue you're always kind of learning it, right? Like you're always like I have to go, man. I go look stuff up all the time, guys. I don't like if anybody thinks I remember anything. Like I don't remember hardly anything. I mean, I it's funny as I get older because I'm in my 40s now. In my 20s and 30s, I was quick. I still feel like I'm pretty sharp compared to maybe the average person, but I'm definitely slowed down compared to myself. Like I can tell. Like I have to look things up that I'm like I should know that. Like I remember when I knew that, but I don't remember what the thing is. it's funny watching it's like flowers for Algernon, right? Watching your memory slip as you get older. But anyways, so let's go look at this. We've got some files here. We've got a prod message of the day and a dev message of the day. And then we've got this push file for it. So let's look at the push, MOTD push. And this push is going to do a very simple thing. It's going to have our 3 dashes at the top to let us know it's a YAML file. It's going to say, here's this arbitrary value about the playbook. It's message of the day push. It's going to run against the inventory host group of servers, which is right here. And in there, it's going to gather facts if it needs to. It's going to become true. It doesn't really matter if it becomes or not because it's already root. And then the tasks are, we're going to debug the variable. So on each node, we're going to have it tell us what it thinks the environment variable is. When we do this, control plane will say, I've got prod, and node 01 will say, I've got dev, right? It will know that up early. Robedom, you're using your data plan? Oh, man, nice. All right. Then down here, we do 2 tasks. We could have done this in 1 task. And I tell you guys often when I show this lab, go figure out how to do this in 1 task. There's a way to do it. But let's just, for now, say I did it as 2 tasks to see very simply what's happening. We're going to do the copy module twice. We're going to push from the prod message of the day and the dev message of the day into the same file, Etsy message of the day, when you have prod in your environment variable. So if you're prod, you're going to get the prod message of the day. If you're dev, you're going to get the dev message of the day. I realize, guys, and some of you that do a fair amount of computer science go, we could have put that in 1. We could. We could spend the time to make this 1 task and maybe save ourselves 30 seconds across 100 nodes or something. But for this and in this lab where we only have the 2, that's fine. Plus I think it highlights what we're doing, right? So we're walking, or actually here we may even be crawling instead of walking, instead of running. Have you guys heard that methodology? We crawl, then we walk, and then we run. That's like a military uses that. You crawl, you look at all the pieces, you do the thing simply, then you get up and you walk. You can like walk through it and go step by step, and then you run where you don't need anybody to help you anymore, right? That's kind of the methodology. So let's push this. Let's see what happens when we push this to all the servers. It's going to push over, and for the first time in any of the playbooks, you're going to start to see these skips. So look, on the node with control plane, it pushed the prod, but it skipped on node 1 because it didn't meet that when condition. And then it pushed to node 01 for dev, but it skipped control plane because it didn't meet that condition. Let's run that playbook again. When we run the playbook again, the message of the day is correct, so it doesn't need to be pushed the second time. But then, let's just go look at what the message of the day is in both environments. So I'll make this a little bigger so it looks nice. Let's run an ad hoc mode, a simple little ad hoc mode, to go look at message of the day on both servers. So now when you log in the environment, you get these big giant dev or prod message of the days. You can also go just SSH over to the node and look, it just dumps that big old, I think it's funny. But you're tired of people messing up because they don't know what server they're on. There you go. But what happens eventually is the server, you get down here, and then maybe you forget what node you're on, right? Like I tell people all the time, like I've watched a lot of engineers over the years. You're working like I'm doing here, where I'm in different environments here, and I'm jumping between maybe my screen sessions, and then you forget what environment you're in. So sometimes, maybe in this case I exit and I come back into that. In this case, I'm just some user on there, but that's, you jump out of an environment, jump back in, so you see your message of the day again. There's a bunch of ways to do it, but my point in saying that is I've seen people make dumb mistakes, but it's because they just don't have some kind of visual cue. This is just ASCII art. You can go find. There's a really good one. There's a really good ASCII art generator. Yeah, this is the one that I use. Pator. This one, I'll link this to you guys. I think this one's great. I'm gonna link it to you guys because maybe somebody wants to go generate some art. But what you do here is you type in, like, let's say Prolog, right? So this is our professional Linux users group, and then you just say test all, and then it'll generate all 320 of them that it has. Also, look, Brazilian Jiu-Jitsu Fanatics is trying to sell me jiu-jitsu stuff. It's because they know they've got my number, and I buy a lot of jiu-jitsu videos. But anyway, so we come down here and look at it generating, like, those are all people. But there's ones that at various levels may be interesting to you. Maybe you want some of these. Maybe you're like, oh, I'm a simple guy like this one. Here's the one that we have. This is the one that we use for this lab. Here's some other ones. And by the way, you could then take any of these and turn these into your message of the day in your server or in your lab. You can personalize your lab any way you want. You guys know that, right? Like, as a simple Linux thing. Some of these are a bit silly for the professional world, but some of these, like, do we need the bears? No. Or these are little devils. Do we need any of these? No. But maybe that one looks pretty good. Maybe you got like a high-speed cluster, and you want to do that, right? Or whatever. I have one that's our high-performance compute one, so I think it says like Prolog HPC. I have that in my notes somewhere, but yeah, you can just come in and generate any text you want if you guys didn't know that. And then these, you just grab them and go drop them in a file, and there you go. You've got your message of the day for your server. Again, some of these are less. I mean, this all works in an ASCII terminal though, which is nice, right? Some of these, they're over the top, but some of these, oh, I could get behind some of this stuff. Some of this would look better in light or dark mode. So, some of this you might want to go test. Does it look good or not? Look, there's your bears. Prolog. Some of this looks worse in a smaller screen, all that kind of stuff, right? You need to think about how many characters across somebody's using, all that kind of stuff. But yeah, look at this. There's like 300 and something of them. And then maybe you get a favorite one, so then you can pick your favorite one. Maybe you're like, oh, I like ghosts. Ghosts are cool. Ghosts look a lot like the devils or whatever. Then you come back here and you just say test all, and it'll go generate, high stream, right? Test all, boom. And then here's what they would look like in the different things or whatever. So, all right. Yeah, so that's a thing for you guys to play with, right? Like, I mean, engineers aren't about, strictly speaking, engineering isn't about cutesy stuff. Like, we're not trying to be cutesy here and no flowery and whatever. But if we can stop our users from doing dumb shit, and again, we don't stop them from doing dumb stuff for themselves. We stop because we don't want to get called in the middle of the night to fix it, right? This is a way to maybe make our lives a little easier. So we hit check. Look at you learning Ansible. You push messages a day. So here's our questions, right? All of this stuff is about the Socratic method. How did we assign variables to the hosts in our inventory? So cat root hosts. Oh, we're on the wrong node. How did we assign? Question here is, how did we assign variables to hosts in our inventory? How do we do that? Well, we just did key value pairs after the host name. And it looked like this. It said env equals prod, right? Something like that. That's a way that we did it. What is the conditional statement inside of the Ansible for testing each variable? So if we go do our message of the day push, then we ask ourselves that question: what is the conditional statement inside of Ansible for testing a variable value. It's the when condition. It's the when condition. We test these things, right? Pew Accountant, Lamau. Hey, hopefully this stuff's useful to you. I don't know if you had followed some other time, but hopefully this stuff's useful to you. We're just working on, again, the method of asking ourselves questions and then doing a lab and then look, we're going back and forth. This is how some people learn. I think a lot of people learn like this pretty effectively. What's our last one? When we execute a playbook, what happens to the servers that are not meeting the when condition? When we execute the playbook, what happens to the servers that are not meeting the when condition? And if I don't remember that, I'm just going to go rerun my play. Just going to rerun it. We'll just push it again. Oh, that's the shell. Where's it at? Yeah, here it is. We'll push it over and see what happens when the things don't meet. And it says we skip. They are skipped. They are skipped in execution. They're not even touched. Users can include other people in the organization, like developers. Yeah, Robodom. I have almost exclusively for the last 15 years only dealt, my customers are always other engineers. They very rarely, and this is probably a good thing, they very rarely have me externally customer. I don't tend to deal with customers that are paying the organization, if that makes sense. I am almost always dealing with internal resources. They have me supporting other engineers who, I try to tell people, the different engineers in your company are going to be smart in their own areas, but they're not going to know Linux like you. They're not going to know some of this automation stuff like you. They're not going to know the environment for sure as well as you do, because you crawl around in the environment all day. That's what you do as a systems engineer and a platform engineer and a high performance compute engineer. You are the environment expert. So a lot of times your team comes to you for help. And I tell people all the time, that attitude, if you've ever seen the Saturday Night Live with the move and you don't know the difference between the uptime of Linux kernel and the number of processors it's run, that kind of shit doesn't help in the industry. It's not going to help you in your career, I assure you that. But that's very common with the Unix and Linux engineers. We get a lot of this. You got a beard and suspenders and you're just an asshole to everybody, right? That kind of stuff. I don't think that helps your career. Maybe some people love doing that, but I don't think. I think that time is gone. The backup operator from hell, the stuff from, if you're familiar with the old register.co.uk or whatever it is, the backup operator from hell, you can't do that stuff anymore. Though you get fired. They'll just go hire another one. They'll find somebody that's less of an asshole, right? But back in the day, they couldn't do that, right? Because you were the only one that knew the system. Yeah, some of those things are pretty funny. All right, so that's our message of the day. Let's do one. This one, it's funny. I tend to lose people on this one. And you say, what do you mean lose people? This one probably over the time that I've done these labs and shown these to people, this is the one that I get the most head scratching from people, and people tell me later I didn't get that one, or whatever. This one right here though, I have to emphasize, this is maybe the most important thing I've learned in Ansible, right here. Look, there's different pieces of Ansible that are all important. Inventory is probably the most important thing to know because you can't hit all your servers if you don't know your inventory. But this right here, I linked it to you guys. Yeah, let me get rid of that other pin. Let me unpin that one. Unpin that message. Can I pin my other message? Hold on. Pin this message. There you go. All right, so that's over there. That's all that stuff. Apollyon, yes, yeah, you don't compile your terminal from source and modify it by writing C. Yeah, I get all types in here, Apollo. I get people, they're like, well, but if you're doing Linux, I had one the other day. He's like, why are you using Windows? And I'm like, where are you seeing me using Windows? I'm literally doing all Linux right here. And they're like, yeah, but the terminal you're in is. I'm like, the terminal doesn't matter to the productivity I'm making. I mean, I could be on my phone doing this. I've managed servers over my phone when things were down and I was, like, it literally doesn't matter how I'm getting to the system. This is Linux. You could be on a Mac. Mac isn't Linux, right? You see what I'm saying? Like, my point is, people get caught up. They let themselves get caught up. We call it bike shedding in the engineering world. It's bike shedding. You focus on the thing that's not important because you're scared of the thing that is, right? People hate being told they're scared, but it's a defense mechanism for being scared because you don't know things. And you know what we do when there's two ways to deal with being scared about not knowing things. You can be honest and learn it, or you can go and keep being like, the terminal I'm in is the most important thing. Who fucking cares, right? I mean, I don't, as an engineer, I don't care like what terminal I'm in, but all right. Because I'm just over here building stuff. I tell you guys this stuff all the time. You're going to find me over there building stuff and getting my stuff to work. It doesn't matter how I get there. All right. But yeah, the elitist, I remember well, it doesn't matter. Lab activity. Your team has decided to stamp servers in your environment so that they know what information about themselves relative to their job functions. So servers, it might surprise you to know this, servers don't know what they're doing. Servers are sitting there running. At some level, this server is literally just doing this right here, whatever these things are. But the fact that it's a physical server or virtual server is largely lost to the kernel. The kernel knows that. You can make the kernel query that, but that's largely unknown. If I turned this into a web server, it would really just be a server with a web service process, but the server itself doesn't really know or care what processes are running on it. I mean, yeah, sure, it affects how many resources you have and these other things. But where I'm going with that is like servers can know things about themselves that you can query through Ansible, and it's almost like they're bringing that information to patching night or whatever. And the process I'm going to show you is actually something that me and one of the engineers that pops on every now and then, Pico, he and I put this together back at Best Western a while back for patching when I was over at Best Western. So let's go look at this. I was their Ansible architect. Cat root host, there's our host file. And then let's cat our root custom fact push. And this is going to push some fact files that we have all over to our different servers. Now we only have 2 servers, but that's fine. If they're in prod, if they're a prod server, environment's prod, they're going to get the prod patching fact. It's going to get pushed to etc ansible facts.d patching.fact. Doesn't have the prod on it anymore. On the dev side, if they've got dev in their environment, dev patching fact is going to get pushed over to that patching fact. Right? Again, I told you this is where I lose a lot of people. Ansible has a default directory, etc ansible facts.d. And in that directory, you can put any files you want with the .fact on the end of them, and Ansible will use the output of that file as part of its variables when it does setup. So you know how you guys use setup, and then you get all that information about a server? You can go stamp specialized facts if you want to. We are going to stamp some specialized facts that are around whether the server's in the prod or the dev environment. All right. So let's do that real quick. Let's go stamp that on the servers. So we cat our root host file. Good. We cat our custom facts push. And then we're going to cat this other one that we're not going to use yet, which is group by. We'll get to that here in a second. But this is going to group your servers by different variables and different things that are going on in them. And then let's just run this push for the custom fact. So let's push this over there. And it's going to push them to all the servers. It's going to create a facts directory. That has to happen on both nodes. But then it's only going to push the prod one to the prod side and the dev one to the dev side. So let's go look at those variables real quick. Let's just, in here, let's cat our prod patching fact. And then let's cat our dev patching fact. Those are the 2 files. They are JSON. They are key value pairs. And they are just going to say things about those servers that maybe when I pull them in for patching on a Friday night or something during a downtime window, those servers are going to have those variables as part of the server. So look at this. So patch group can be 1 or 2. The dev environment is obviously my group 1. And the prod environment is obviously my group 2. That's something arbitrary picked by my company or picked by my team or whatever. It's just some arbitrary value. And then I have rebooting true and rebooting false. So in this case, my prod environment, rebooting is set to true. And then now later, if I'm going to reboot because maybe a kernel update or something like that, I could go look at the rebooting variable and know whether or not this server, for whatever reason, is or isn't allowed to reboot within the window. That could be something I know, and not that I know it, the server now knows it about itself. We can know if it's an app server, a database server, a web server, based on the name, based on whatever else we want, but these are just key value pairs that we've put in there. So in this case, when we stamped these servers, we decided to say that they're all app servers. Maybe app servers get patched from a different repository that we only attach during patching, because we don't want people changing things in other windows, right? App server would allow me to go make decisions inside of Ansible based on that, right? But the point is, if nobody knows what these things are, if something doesn't bring that information to the table, I can't make decisions on it. But now that I've stamped it, I can make decisions all over based on it. So let's go look real quick at run a custom variable. So now we can group them. But before I do that, let's run an Ansible ad hoc play. Let's go do this, and here's an ad hoc play from this. So Ansible, we're gonna hit servers, and then root hosts. And the only thing we're gonna do is -m setup. The M setup module is going to dump everything to our screen, right? Just a whole bunch of info. You didn't see me do anything else except make a directory and push those files over. I'm going to go up and look through here. I'm going to go, there's a lot of information here, a lot of information. I always tell you guys there's so much information. Ansible _local .patching, which is the name of the patching.fact. Here we go. This is something now that the server knows about itself. So, I should be able to go like this. -A, and then filter equals Ansible local. Let's just do that. Here's all the Ansible local variables for my system. Let's maybe go. Let's just do something manual. Let's say that control plane or node 01. So we SSH over to node 01. We CD over into etc Ansible, and then facts, right? And then I copy my patching.fact over to streaming.fact, right? And then I VI my streaming.fact. And in here, I say something like this. I say streaming, and then we say yes. And then maybe we come down here, and then maybe we say, I don't know, Twitch. Doesn't even matter if it's there. And we say that's true, right? You can do true or false or whatever. And then maybe we YYP. It's JSON, so you got to remember your commas, right? You got to comma separated value everything. And maybe I send this over to YouTube as well, right? Maybe that's something I know about my environment. So all you guys saw me do was go put that file out there. And I'm going to rerun my playbook right here against all my hosts. And we're going to see, do my hosts now know this streaming fact? Because all I did was put a file out there. So you might look at this and go, okay, well, that sounds real manual, Scott. Like that sounds like a big hassle. Yeah, but hold on. We can automate this process. We can have set things that we want to know about our servers as we build and deploy things from like way earlier in our labs. As we build and deploy things, we stamp things to the server. And then I can come back later and I can look at that server, and one of the questions I could ask is, hey, was it set up with, deployment 4512 of the dev New Relic setup? New Relic is a tool for like monitoring stuff for the apps. And, you know, we go and we run something like this, a quick little setup of our Ansible local, and 27 of our 30 nodes have it, but 3 of them don't. They've got New Relic on them, but they don't have our stamp from our playbook running. What does that mean? Those 3 were one-offs. You say, how can you prove that? I know for a fact that my playbook that did all that stuff and then stamped those values isn't there. It can't, you know, so I didn't do it. Somebody else did it, or maybe I did it as a one-off as I was prepping and stuff, and then I should, oh shoot, guys, I forgot to go and rerun the thing and redeploy it with the proper values when I was done. Those were my 3 test servers, right? Something like that. But the point is, I know now, and you guys have no idea. Like, some of you do, because you were around yesterday and the day before. If you watch me do stuff in my home lab, you're like, how does this guy get anything done? The fact is, I use stuff like this to help keep me reminded of what has happened in an environment. So this is super useful for like what's going on, what has or hasn't been stamped with certain values or those kind of things. Anyway, so let's go do this. Is really the crux of this. When you start a playbook, when you run Ansible, Ansible keeps all these variables with you. So let's go look Ansible variables and special variables. These are all these variables that will always be there with Ansible from the start of a run through the end. All these things. And you can check them. You can know exactly where you're at in a loop. You can know exactly what parent role is happening at any given time. You can check that. One that you guys see me do often is what is the play hosts that we currently have and what did we start with. So play host and play host. All kinds of stuff that you can do. Now, that being said, one that's huge is here's all the groups. It's a dictionary map with all the groups in the inventory, and each group has a list of all the hosts that belong to it. So we're going to look at the groups in this playbook, and we're going to see what groups that Ansible starts with. Then we're going to set variables, and we're going to create groups by tagging servers as we do this lab right here. Where's he at? Cat group by. We're going to see all the group names to start. Then we're going to set and group the servers by different variables that they have within them. And then we're going to look at all the group names at the end. So we're using a special variable called group names, which comes right from here. List of groups of current hosts is in, and it reflects the inventory host name and it ignores the delegation. So this is going to be the start of how the server came up, and then the group name as it's running. So let's come over here and let's run it, right? This is one of these things where we just run it and see how it behaves. So look, when we started, here's the server. Control plane belongs to servers, and node 01 belongs to servers. Those are the only servers that they are part of as they start the play. Then we group them by reboot group. So things that belong in reboot true are going to go one way, and reboot false are going to go another way. And then we're going to check the rebooting flag, and if it's true, then we're going to put them in a rebooting group. And then we're going to show all the groups at the end. So this is the same play from up here, but at the end of the playbook, they're now grouped like this. Control plane is in rebooting, it's in group 2, and it's in that original group of servers that it was in. Node 1 is in group 1 as opposed to group 2 and servers. So I want you to, I know that this is an abstract concept what I'm about to talk about. I know it's going to sound really silly, but you're starting at the top of like a execution, but I always think of it like a little Plinko machine. So I drop 2 servers in at the top, and they are assigned as servers. Then as they bounce around through this little Plinko machine, does everybody know what Plinko looks like? It's like an old game. This is what a Plinko machine looks like. You've never seen it? It's just a silly little game where you drop balls. It's useful for like standard deviations as well. Come on. Open image in a new tab. There you go. You just drop things in and then they bounce around. I guarantee you most of you have seen that. Yeah, very popular in Japan. Yep. So you drop steel balls or little tokens. Sometimes people use like flat tokens, and they bounce around and they land wherever they land. When a server comes in, it It's bringing all this stuff with it, these things that we just stamped it to, and then we make decisions. We can make all kinds of decisions about other stuff too. We can go based on the Ansible distribution. Ansible distribution can be Ubuntu, it can be Red Hat, be all these things, and we just start plinkoing our servers different directions. Maybe you want to call this logic trees, or maybe you want to call this decision function. Whatever the hell you want to call it. I literally don't care. This is how I think about it right here. It's decisions that are happening in the there's Plinko from stuff that wasn't there. So the point is, it wasn't there at the beginning, and then we went through these steps and we put them in these different groups, and now we can use that group information to do things against those servers. Now, you might also say, well, couldn't you just, you've got those variables set, couldn't you just make decisions as like when conditions and blocks and stuff? Yeah, you could do that too. But maybe you want to actually group them up and then print out the groups at the end or something. That could be a thing. Because then maybe you care about why servers did or didn't get things to happen to them. We're only doing 2 servers in this lab. Normally when I do this, I'm dealing with hundreds, if not thousands of servers, right? So I want to know where all those servers went, and I want to carve them up and do this. Again, this is one of the most useful things I've found to do in Ansible, period. Inventorying, huge. Splitting out your inventory into the right decision paths, also huge. So there's that. Okay, look at you learning Ansible. You pushed custom facts and then put them into different host groups, right? So then we come over here and we say, what do you think? I say, why do you think it's so important to create the directory Ansible, Etsy, Ansible, facts.d on all servers? Well, there's 2 reasons. It has to be there for Ansible to pull facts from, custom facts from. And the reason you have to do it is not all servers have Ansible on them. So if not all servers have Ansible on them, not all servers are going to have Etsy Ansible facts.d on them. So that's why when I do this, I have to create it like that. So that's why. Inspect the files you're pushing over. What is their format? Let's go look at them. We know the answer, but let's look at them anyways. Cat and dev. What's their format? JSON. And that is key value pairs, right? Which, well, most of JSON is key value pairs or dictionaries, right? Ah, the price is right. Yeah. You know what? I was just that popped up the other day on something. I don't know why that popped up, but the price was right. Was up the other day, and Drew Carey was on there or whatever. Isn't that him? Yeah, Drew Carey. What's his name? Guy lost like 100 and something pounds. If you remember the Drew Carey show, he was way heavier in that show. So now he looks kind of like a skeleton. All right. Yeah, I don't know why that was on the other day. I don't know if I was at somebody's house or something. I was just watching The Price is Right the other day. Anyway, somebody said it on the Heather said it over on the YouTube side. So, all right. What is the module group by doing with the different keys? So let's go look at that. Let's clear this up. Let's cat out that file, which is group by, and it says, what is group by doing with the key? It is grouping by the different keys, and in this case, it's going to group you by your patch group, which is either like group 1 or group 2, right? So the key is the name of the group that is being set. So if we had more groups, we would be getting more keys from that. All right. And then it says, why does only one of the 2 servers have the rebooting group? Why does only one of the two servers get this one? Because rebooting here is true only on one of the servers. On the other server, it's failed, right? And it's the logic. So it's the logic of whether or not true was in that variable. And if we rerun it, we'll see that it doesn't get, only the server that had rebooting true was put in the rebooting group. And now I can use that logic later to only reboot those servers. And again, you might say, well, Scott, but couldn't you have just had like a when condition and then done that? Yeah, I could have. Yeah. Maybe I didn't want to see all the skips. So I only do rebooting against those rebooting nodes, and then I have that come out as like a Jinja template back with like a report of all the servers that were supposed to reboot that didn't. Or I only test those ones for, you know, you guys have seen that little diddle I do where I say, it's DITTL, whatever. It doesn't matter. You've seen where I go and I check if day is in uptime, because if day is there, the server hasn't rebooted in uptime. That's like a cheap little trick that I do. And yeah, there we go. And how might we use the group? Well, we would only use the rebooting group to reboot the servers that we want to. Or these servers need to, you know, if you're not in the rebooting group, you are not authorized to reboot in this window or whatever. And then maybe we even have overrides. Maybe you're allowed to reboot in certain windows, so now we got to go split out our variables. So rebooting Patch Tuesdays or rebooting third Thursdays of the week. And we can have different names for these variables that make sense to us around when we reboot stuff. And this right here is a very tame version. This stuff right here, very tame version of like what me and Pico put everywhere over at what's it called. And by the way, you can have patch groups assigned to your servers inside of Satellite, and I can pull this stuff out of Satellite and automatically assign everything, and then we can override these variables later if we want to. Guys, there's a lot of stuff you can do. Yeah, Robodon, thanks for coming around. Yeah, boring work stuff is never fun, but I won't be on too much longer. I've been streaming for over 2 hours, so we're doing labs, right? We do labs on Sundays. That's what we do. We've done 9, 10, 11, 12 now, and then a different lab. So we've done 5 labs now. All right. So let's get out of here. And I'm just doing the Socratic notes as I go so that I can put them up in the Discord later. Let's do our create users lab. So we've done all these other things. Now we're going to create users on our different servers. This is, maybe something you do. Most of the time, systems engineers nowadays, we're not in the business of building users often. We let our identity and access management teams do that. We tend to set up the, what we call the trust authority. We set up like the trust authorities so that like we trust Active Directory or Keycloak or whatever the different tooling is. Our servers don't have to worry about the authentication part of it, right? We let some other tool deal with that. So lab activities here, your engineering team need, here, I'll link this to you guys, hold on. Boom, boom. Pin this over here for Twitch. Pin, boom, okay. And we are lab create users. After you've executed the playbook, what is the difference between prod and dev engineer? What do you see when you grep them in sudoers? All right. So let's go do this. Your engineering team needs to push service accounts. Maybe in some, dev environment, you just need to do a quick and dirty system user build. This is a tool. Again, I can't tell you all the times you may or may not use certain things. I'm just kind of here to show you that you can do things, right? Let's create a host file. So cat root hosts. We see that we've got the same control plane and node 01. They're an environment prod and environment dev. So they've got their pieces. Let's verify. Let's cat this root user create file. And we come down here. It's very similar to all of our other starts. We got our tasks. We're going to debug our environment variables just so we know that the nodes are in these other. Strictly speaking, you don't need this, but it's going to show that you're in prod or dev. And then down here, if you're in the prod engineer, So if you're in prod in the environment, we're going to make a user called prod engineer. And if you're in the dev engineer environment, we're going to make a dev engineer. We're going to give a comment, and then we're going to make a special group for you. But we're not making the group. You've got primary and secondary groups as a user. You can have one primary group. Typically, the primary group follows your name. So like the prod engineer is going to have a group made for him called prod_engineer, and that will be his primary group for a user. It'll be kept in his Etsy passwd as the fourth field, and it'll just be the number, but then it'll map down to Etsy group, right? Dev engineer is going to still have dev engineer as his primary group, but he's getting a secondary group. He's going to be added to admin. So if you go look in the Etsy group file under admin, you're going to find right at the end, the last colon, then determines all the additional users that fall under that group. So dev engineer is going to get put in there, right? So we're going to make this with Ansible, though, so we don't have to go do it by hand. With 2 servers, you might go, Scott, probably longer than you just explained this. I could have went and made those, and I say, sure. But could you make it across 100 servers without making a mistake? This keeps us from making mistakes, keeps us from fat fingering things. You know, I can't type anything without making mistakes anymore. So I'm gonna do this and very quickly make sure that my stuff works. So let's go run. We looked at all that. Let's run this everywhere in our environment. Let's see if it builds the stuff like we expect to. So made the users in both environments. And then maybe I go check, and I'm gonna go look at those servers with a little ad hoc command. And we see dev engineer is also an admin as, again, like I said, a secondary group. But over here on control plane, there's nothing in admin for the prod engineer. The prod engineer is not in there. So the question over here is, after you've executed the playbook, what is the difference between the prod and dev engineer? The dev engineer is an admin, is in the admin group. Now, does being in the admin group make the dev engineer an admin? This is not a philosophical question. This is an actual very important sysadmin question. The answer is, I don't know. But I'll show you how to find it out. Let's go look in Etsy sudoers on that node. So SSH to node 01. And let's grep admin from Etsy sudoers. If you are in the group admin, you are an admin on this box. You can do any command. If I do a sudo -l-U for dev engineer, he has the permissions as an admin on this box. But if for security reasons, or just because I wanted to be an engineer that did not allow that, maybe my security posture of my organization doesn't allow admin to exist. It's a read-only file. Put an exclamation mark. I'm root. I can do what I want. Now when I look at it, the user is not allowed to do sudoers because the group that he's in, admin, no longer has the sudo permissions. So I wasn't saying that to be tricky. This is an actual thing. We may have turned off certain permissions in our environment. Okay. The reason it's giving me that's a read-only file is you're not supposed to edit sudoers like I just did. You're supposed to use vi sudo, and then this. Oh god, what the hell is that? I don't even know how to use that. Get out of there. Ugh, nano. Shit, scary. I think that's like the first time I've been in nano in years. I don't even know how to get out of that thing. I definitely don't use it, but anyways, it's going to use whatever your environment. You could set your editor to VI, right, if you want to. But my point in showing you guys that is you could go in and you can change sudoers, and it'll only change if it tests as good. That's what VI sudo does. So you got all these things, and it says, what is the difference between the first playbook and the second? So let's exit out of here. Let's go run the second playbook. So we did the first task. We built a user. Now it says verify you've got this root user key. So cat root user key. And now we're going to do the same debug. This top part's all the same. But then we're going to create a prod user, and we're going to generate an SSH key for him. And then we're also going to do the same thing for the dev user, And we're going to set an SSH key up for him as well. Everything else is the same, right? Let's go run that playbook. It's going to go generate keys for the users, right? Yeah, nano. And then we come in here and let's go look at, on both environments, we've made these ID underscore RSA, which is your private key, and ID underscore RSA.pub, which is your public key for those users. And then our public key can go be pushed to the whole environment, and our private key is kept close to us, and then we can use that to, as long as the public key is added to the authorized host file, authorized keys file. Yeah, authorized keys. Let's go look. Where's my SSHs here? Hold on. Just go in any one of these. Let's see. Yeah, authorized keys, that's what it is. My authorized keys file has the keys, the public versions of keys that are allowed to, with the proper, with a user coming in with their private version of the key, they are able to prove that they are who they say they are and authenticate to my system, right? Yeah, it's authorized keys. I always forget that. I always have to go check that, right? I don't always forget it, but sometimes I do when I'm talking about it on stream. What's the difference between the first playbook and the second? Where are the keys created? All that stuff. So what's the difference between the playbooks? The second one generates RSA keys. What did I say? Where are they created? They are in the home directory. Oh, man. They're in the home directory under the .ssh directory. All right. There we go. All right. Are the keys created with the right permissions? What are the permissions? Let's do this same command, but add a -L. The private key should not be readable by anybody but the owner of the file. So that's true. They've got read-write for the owner. And everybody else can't read anything. Yes. And then the public key can be spread far and wide. So there's read permissions for the owner of the file, the owner ID. The group ID has read. And everybody else on planet Earth has read as well. So owner, group, everybody. There you go. So yes. Are the keys created with the correct permissions? Yes. And if we wanted to see those permissions, they're right there. So public, anyone can read. Private. What? Public. Private, only the owner can read. Right? There you go. Boom. So, yeah. So we created users, we checked them, we built some keys for them and generated keys. So you won't generate keys for your users often. My advice would be teach your users how to generate keys, or have like a little wiki out there, or send them to a field manual they can read about it. But I can assure you one thing: users that do not use Linux systems often will be scared shitless of making their own keys, right? They won't know how they work. They don't know which one they need to keep. And this is one of the things I tell you, like, as engineers, we don't get to just go move. And, if you don't want somebody asking you again in 30 days or 60 days when they go to a new environment or whatever to set up the shell again, it behooves you, in my mind, to just teach them how to do it. Teach them the basics of it. Tell them, hey, there's private key and a public key. If you see that .pub, you can send it to anybody you want. Private one, never showed anybody. It's right here in the permissions. And they'll go, I don't know what they are. Well, the one with less has less permissions. There you go. Because again, we don't expect even with, man, I'm telling you, even with like front end and back end admins, and I mostly tell you guys, I support hundreds of dev teams. Just because somebody's a dev and just because they're really smart does not mean they play in Ansible and Linux all day. Most people do not play in Linux nearly as much as any of you that are doing it professionally. So this stuff right here scares the crap out of people all the time. It does, and I know really smart architects and principal engineers that just aren't in there as much as you. So keys for GitHub are probably a huge headache too. Yeah, keys for GitHub are a hassle in general. I've had some trouble setting those up in environments for people, right? All right, so anyways, look at you learning Ansible. You did stuff. All right, so we did another lab, knocking labs out. Now we're going to do some package stuff. So the next lab is going to be package type stuff. But let's go take a quick break, check on Ranger Dog, and I'll turn myself off here for a second. Oops, go back to Ranger Cam, and let's put up our little hourglass, and we'll say, move it over here. Break and check on Ranger, and we'll come back. Feel free to take a break if you guys need to, and we'll do more Linux, specifically Ansible stuff here shortly. We'll do package management next. All right, I'll be back. All right, Ranger's down there munching. All right. Still taking a break. Feel free to relax for a little bit. I could have put us on intermission. I don't go there very often here. We won't hang out on intermission too long. That's old. That's from when I first started streaming right there. By the way, there's an error in that. If you guys see the error, feel free to let me know. There's actually an error. There's a logical error. Oh, the loops worked. The loops are no error. But I have a logical error in there. What we call the difference between a syntax, a runtime, and a logic error, right? Syntax worked. Runtime worked. But the logic of what I said has failed. So, anyways, alright, get out of there. We're back over here. Alright. Wait, when I'm on that, you guys can still hear me, right? I'm thinking about it. I'm like, wait a minute. Do I have a source for that while I'm on that? I'm pretty sure I do. Alright. Anyways, we'll get back to this here in a minute. Ranger has eaten all of his treats. He is happy. And we'll finish up more. I don't think we're going to finish all the labs today. We got a few more to do. And I'm probably only going to be on for maybe one more. Alright. Ranger's got to lick in between his beds to get all the tasty crumblies. The zero. No, it's actually something else, Daff. It's something more. I'll put it back over here for a second. There's something in the way I wrote this that's incorrect. And it's glaringly incorrect when you notice it. Oh, the condition. These are real loops running. This really happened. So the logic's right, or the syntax is right, and the actual running of it is correct. But there's something I wrote that's incorrect. It's 4 loops, and it's a counting loop and a conditional loop. That's right. But yeah. Let's leave that on for a second because nobody cares about Ranger licking his bed a whole bunch. I could actually set up that intermission to also have the little timer on it, I guess. But we're fine for now. All right. Let's go over here. Alright, let me pop myself back on here. Let's get rid of this. One more minute. Yes. Ah, Daft Duck, you got it. That until is false. You're right. When I wrote it, I said it loops until this is false, and that's not true. It loops while it is true. So that is the correct error. So Daft Duck got it. If you guys look back here real quick, there's an error right in the second loop, right as you get down to right about here. It says conditional loops for iterating until a test is true. That's not true. That's not how that's working. It's iterating while a test is true until it becomes false. So, yep, that's exactly it. And that second part, the way that I wrote the conditional looping, like the way I wrote that text, is incorrect. The loop itself is correct, but what I wrote about it is false. And I just didn't want to re-record it, so I left it, but then I call it out every time. So conditional loops for iterating while a test is true. So, all right. Anyway, so we're back. There's Ranger, and we're on package management. So I come over here, get rid of my special variables. I linked those earlier. Did I put those in the notes? I have playbook for, oh, well, that's fine. That's fine for now. All right, so we keep going and we say package management. So we come down here and we go to push all the facts to servers, create users, and modify packages on a server. So this one here, I'll link to you guys on the YouTube side. There you go. I'll link to you guys on the Twitch side. And this lab starts out with, your team has been tasked to update all servers in the environment to maintain compliance with your GRC team. So your security team is going to come to you, and they're going to tell you stuff, and they're going to ask you stuff. But the GRC team is your governance, risk, and compliance, right? You also need to configure some new servers for software in the environment. So we're going to add some stuff to the environment. So come over here, and we cat root hosts. And there's our basic host file, right? Our inventory file with our host group servers. But now we've added more variables. One of them is going to be an app. One's going to be the app for it is a database, and the other one is app web. So we could have done this. The key value pairs could be a bunch of different ways. I just happen to say the application on one is a database and the application on the other is web. You could call it whatever you want, right? Maybe that logic doesn't work for you in your organization or where you've been, but the point is it's some way to differentiate the server so that we can do whatever discussions we need. You also need to configure the software. So let's go look at our packages update. So cat root packages update. And our update is really easy. It's just going to go and hit all the servers regardless of where they are and give them the apt module against all the packages they have updated to the state latest. So if we run this first one, let's go ahead and run the first one because we need to spend a little time. We're going to let that run for a little bit. This is going to sit and spin in the background and just upgrade all the packages on the servers to the latest version. So that's going to take some time. And then we're going to run it when we're done. We're going to run it again to see that it runs much faster the second time. If you wanted to, you could do a time command in front of it so you see exactly how long it takes. I think it takes about 3 or 4 minutes the first time. It says right here, what is the new variable in the lab you're seeing? So what is the new... What's the new variable that we're using? We're using a variable here called app. And that's just a new one that's popped up in this lab. Why does the upgrade take so long? And then how do you capture how long it takes? Right? So it takes so long because it's updating everything. And you could put prepend with the time command to see how long something takes, right? Like that's a basic little Linux thing. You can always do time to see how long something's taking from a command line. Time gives you 3 outputs. You've got the actual wall clock time, what we call it's the real time, or most people call it the wall clock time of how long a big project or a process takes, right? We use that a lot in the high performance compute world, what's called the wall clock time. That's real time. The other 2 types of time are how much user space time, how many user calls did it make against the kernel, as far as time goes, and how long did that take, and then how much system time did it take. We'll look at it here when we run it again, but it's going to show how long those things take. I should have run it for this one originally, but it doesn't really matter that much. You'll still see the same output. You just won't have the first one to compare with, but we could very quickly look at it and go, well, yeah, it took a long time, right? But if you want to know how long a command takes to run, you put something in front of it. So I'll show you here. I'll come over here in a new tab, and I'll just say in this new tab, time sleep 10. And it's going to give us 3 times when it's done. Look, we told the system to sleep for 10 seconds. So real time is going to be about 10 seconds. But then there's going to be 2 other times. So the real time was 10 seconds, almost exactly. But the user and the sys time against the kernel, hardly anything. Nothing, in fact. So you can do that with other commands, right? Like you can time your DD to see how much system time was being done and how long it took to write to a directory or something like that. Time is a great command for figuring out how long stuff takes, right? And how busy the system is while that command is going. So time is good for that. Come back over here. Node 1's done. Control plane should almost be done in a second here. And then we'll run this with time around it as well. Time doesn't gather individual things. It's like a stopwatch around the whole process until it returns back control to your system. If you want timing inside of Ansible, you have two ways to do it. There's these things called callbacks. There's profile_tasks, which is one, and the other one is called timer. Timer and profile tasks are useful for knowing how long things took across the cluster. So we don't have those turned on. You know what? Hold on. Lab to do. Do I have that? Hold on. Do I have that in my lab to do? Hold on. I need to add callbacks, profile, tasks, and what was the other one? Is timer. I need to add those because those will be a useful one to do in the future. All right, so we come back here. Hold on, and we go to where were we at? Socratic Ansible notes, right? And I have that small so you guys can see this the other part of the system here. That's why I don't have this as big. But okay, that got all done. Let's run it again. Whoops, let's run this again. But let's run it with a timer around it. And you might notice that time doesn't really have, well, one, it's going to go fast. And two, time doesn't really have a lot of load against the system. Like, look, user space and system space isn't very high. But that's because Ansible is making just call-outs, SSH connections out to different stuff, right? The second time it ran, it only took about 5 seconds. Whereas the first time it took like 5 minutes. Well, why did it take so much less? Well, because there was nothing to update. And if you needed to see what has been updated on the servers, you can cat var log apt and then history, right? And history in here will tell you these are all the things that were updated on this system. Right here. Look at all that. The command was this command here to start the kickoff of all packages. That's what actually got called apt-get y-o package and then everything, right? That's what happened under the hood. If you want to know what that module called without going and taking the module apart, there you go. You can also go take the module apart. You say, I want to go take the module apart, Scott. Okay. This is not part of the lab, but you want to know more about how the Ansible is doing the thing. Come in here and add a bunch of these to this. And it'll be verbose about all the things it's doing. And then go and look for, this is what it did, right? But if you come up here and you look for the package where it got pushed from. So there's a SFTP that's going to happen. When it copied it from this machine over there, you're going to see it right here, this SFTP. And where did it come from, right? Where did the system go and grab that module from? Should have module file this. So I can go VI, I'm root, right? I can do whatever I want in a Linux box. I tell you guys, none of this stuff is unmodifiable for you if you're a Linux admin, right? Come in here. Oops. Here we go. We're using user bin Python, and here's all the stuff about this module. If you want to go modify how a module works and how it behaves with arguments you give it, you have full discretion to do that in your own systems. Are you going to break stuff and maybe cause yourself problems? Possibly. Or it may work, right? But this is what we do, right? This is as engineers, if you need to go, oh, here's examples, by the way, if you need to know how the module works, all these examples. Then we come down here, and this is what the module is actually doing. Import warnings, import all these things, and then it's going to go do all this. So if Python's your jam, and you want to come in here and change the way that it actually does different things, there you go. But that's a way to find it. You go and you run the playbook, you see what it's doing, and you go grab the file that it's doing in. And that's the one on your actual system. That is changing in, well, that's changed in newer Ansible. Newer Ansible, everything is either packaged with it or is a separate, so it's either like a Ansible.built-in or an Ansible dot like some kind of plugin, and you can download them separately and stuff. So I expect that that's different in newer Ansible, but in older Ansible, that's where it is. And if I didn't know, I could find it. That's the most important thing, is I don't need to know what version of Ansible I'm on. I know how to go find it. So, all right, we did all that, and we ran it twice, and it was faster. So now we're going to do a packages install. So let's clear this up, and let's more our root packages install. We did our update. We updated everything. And now look at our packages install. If you are a web server, you get Apache and PHP. You get them looped right here inside of packages. So package is going to be a list, right? That's a list format in YAML. And if you're a MariaDB server, if you're a database server, you get MariaDB server and client. And the state is present because we're adding them in. And if we run this, it should just go ahead and push those packages to those nodes. It'd be pretty fast. It'll push the web onto the web, skip the database server, and then it'll push the database stuff to the database server and skip the web. This is like the start right here of like an environment conditioning. Like if you want to set up, you have like a set of like 10 servers that come up when a dev pushes a button and gives them a little dev environment, but then you need to like condition the servers to be, you know, they need a web environment and a dev and some of these other things, and this is the start of how you could do that. I would try to be a little more efficient and stand up the server and put these over them as they come up, so it's, you know, 3 nodes and that's exactly what they need. I wouldn't give them a big 10 node cluster nowadays. You know, I'd be like more precise, but the point is you can configure things as they stand up, right? And Monospace Mentor, hopefully this stuff's useful to you. Thanks for the follow on the Twitch side. We are doing labs all day today. That's what we're doing. The second run was faster. Let's see right here. Why does the upgrade take so long? Was the second run faster? Yes, because there was nothing to update the second run. All right, this should be done, right? So it deployed those. If I rerun it, it's deployed those things. And you might say real quick, hey Scott, could we just do like a quick little sanity check? Is Node 01 a web server? And I say, yeah, is it a web server? Curl Node 01. It looks like a web server to me. Green terminal text. Instant follow. That's funny. Yeah, in fact, I use green on some terminals, but Ansible does a lot of that stuff automatically for us too, so that's always good. What package gives the app module? What is the argument given to the apt module? So let's go look at this. What's the argument given to the apt module that says to install packages? It's the package module by name. So what is the argument given to apt module to install packages? And that is package, PKG, and then called by package name, right? So you give the actual package names as you kind of go. Remek said, can I ask something about the work environment? Sure, Remek, if you want. Yeah, I'm not doing anything here that relates to work. Well, I mean, as far as the work environment, but I can show you this is the exact same environment I work out of for professional stuff. I just jump into the different nodes inside of from a putty session. So, but yeah, you can ask me whatever you want, Remek. Yeah, absolutely. Then if you keep running things, if they're idempotent, then things will happen again without causing any actual changes. So I'm going to drop this idempotency thing here, just so we have it. There's a little link for everybody. And then what is the format of the package argument given to the apt module? And it is list format in YAML, right? So a list format in YAML looks like this. And the question here is, can you give this, could you give this another, you know, package? Yeah, I just go like this, YYP, whoops, YYP, and then right here, I would say something like, I don't know, calce, right? And then now when I rerun this, my server has to, only on that one node, is it going to have to update because now it's got this new package that it needs to install, which is Calce. Calce is like the stupidest little package ever. And now it's there. Then if I run it again, it doesn't have to happen again, and it's there. So, can you install, stress. Can you install stress to the web server? Yeah. Right here. YYP, change this to stress. That's another tool. Stress is maybe we want to stress up the server to a high load and then see if it still serves web pages. That kind of stuff. All right, so there's that. Real quick on the YouTube side, Remick said, I'm a Java developer. I have a situation at work where the product owner asks me about my progress every day during the daily. This is starting to make me feel pressured to deliver tasks faster. Additionally, he emphasizes the importance of quick development. On the other hand, it's hard for me to stand up to him and tell him that I don't need to be hurried and rushed. I feel like he is using sprints and daily meetings as a tool to exert pressure. Yeah, Remick, I can tell you that's a pickle, right? That's a, by the way, guys, pickle is a, if you don't know, pickle is a baseball term, right? Where you're stuck between two people throwing the ball back and forth and you're stuck. That's called a pickle. But let me tell you, so a lot of people use that as an expression for like you're in a pressure situation. Remick, what I would do is I would say, if you think that the person is using it to exert pressure, what I would do probably is just make sure that they have like good expectations. Like, hey, if I know something, so if I know something is not going to be done for 2 days, but somebody asked me about it the day before, I would in that meeting, I would let them know, hey, I put this in a message, but I'll go ahead and reiterate that's not going to be done until tomorrow. But like if people want progress of each individual part of it, I would maybe just give them the same thing, like, hey, yeah, my team's working on it or whatever. Because I haven't dealt with that exactly, but I've seen people do things in meetings that are, like a lot of the things that people do in meetings, like sometimes they don't know they're doing them. Sometimes they do, but typically if you like call it out and like bring it to light, people will stop doing it. So if you say, hey, this is actually in like a Slack message, or I sent you an email that it's not going to be due till Thursday, I don't think we should address it every day between then. That's fine. Now, I'm gonna preface that with something. If that person has a history of not getting things from you at Thursday when you've said you will do things, they are, by the way, this is the only reason project managers exist, is to ask you stuff every day, right? So you got to know that. Yeah, I'll share my Git repo. Hold on. I got a question to do my Git repo. I am, guys, some of you know I'm not a developer, right? I just do things out there and put things out there. Thanks for the follow, R22K20. Hopefully this stuff's useful to you. Over here for Remick, though, yeah, I would tell you, like, you got to remember, project managers and stuff, they don't exist for any other reason than to ask you questions. So if they're worried that something's not going to get done because you've told them, oh, I'll tell you on Friday, they might ask you every day. But what I would do then is I would just feed them more information. Like at the end of the day, I would just send them an email and be like, hey, here's where we got to by the end of the day, me and my team, or here's where this is at. We're still on track for Friday. And then they don't have to ask you. And if they do ask you in front of people, then you go, well, okay, I guess I'll tell you what I just told you, right? If you want to like turn it back on them, say, hey, I thought I sent a status at the end of every day because that seems like a more appropriate thing for like me as I stop. That's my stopping point for me and my team or whatever. But here's my update. So hopefully that helps you, Remick. I can tell you that a lot of stuff like that, I find there's two types of people out there. People that don't realize they're doing asshole stuff in meetings, and people that do, right? Either one of them, when you kind of call them out on it, then either one of them, they've got a choice. I think most of the people that don't realize they're doing it, stop. People that do realize they're doing it kind of have to like keep doing it, but then they at least realize in front of everybody that they're being a jerk about stuff. Do you see what I'm saying? Like, I'd just take the wind out of their sail. I would just send them an update. Send them an update and say, oh, yeah, oh, sorry, you must have missed my update. And I would say that every single morning to them. Oh, because I'm an asshole. But I'm also an engineer's engineer. Like, I engineer things. I build things. I'm not in the business of being a project manager and stuff. I think some of you guys know, like, I have 2 master's degrees, but one of them is in business administration. And I joke all the time about everything I learned in my MBA which is an emphasis in project management, can be summed up in one sentence. There's this old saying about, I can do cheap, fast, and good, now pick two. That's it. If you guys have never seen that before, do you have finished? I have all kinds of finished project, RK. Yeah, R22, yeah, sure. Yeah, I have all kinds of projects that I, run around here. And then I have a Discord where we have like a lot of kind of like training material for people that want to get into doing Linux more. And I tell you guys all the time, the professional Linux users group, their goal is to get you guys doing this professionally. Most people do this stuff as a hobby, and this is fun, and this is whatever. But you can go make money doing this stuff if you want. So that's a thing to think about. Okay. So we did package management. We're answering our questions down here. We're using a thing called the Socratic method where we ask ourselves questions, and we did all those things. So I think we beat that one pretty good to death. Let's go and look at galaxies and roles. So we're going to start to do, this is really, when you look at all these labs I've got, right? The labs are here under Killer Coda. Lug is how I learned most of my Linux early in the... Yeah, nice. Yeah, I actually got the name, the Linux users group, because we used to have lugs back at DeVry when I went there in the early 2000s as well. We had Linux users groups, and I ran Linux mostly through college. I ran like a full Linux desktop. I did Ubuntu early on because it was just an easy one to run. And I did like most of my early college years on that. But anyway, so when we first started these labs, we set up this system, and then we did ad hoc mode. And then we jumped from ad hoc into playbooks. And playbooks were cool because we could run these big plays and stuff. And then now this galaxy and roles, when we get all the way down here to galaxies and roles, where we start to inherit roles, this is really where I think Ansible starts to become like kind of like a next level tool. This is extremely powerful when you start to get your roles and stuff set up. In my home lab, if we exit out of there, where are we at? These are all the roles in my home lab that I have set up over the years and when we were doing stuff that can do different things in my lab. So there was one, do I have the one here for, let's look at one. I used to run this one on stream all the time, AWS Ansible lab. So more AWS Ansible lab. And this playbook, all it does is inherit this role called AWS Ansible Lab. That's all it did. So then we go down, and it's got an Ansible vault, and that vault would, I think, give it some keys or something like that. So we CD down into roles, and we go look at our AWS Ansible Lab. And in here, I had in my tasks just some things that would go. It would call my local vault, and it would read a secret for my AWS credentials and generate AWS credentials for me for 10 minutes, debug them if I wanted. And then I would go and I would send this Terraform information out, and the Terraform information would run and build whatever I needed to out in the cloud so that people on the stream could hop into these servers that I used to run. Then I would report it out to Discord. And when I used to do this, it would pop up in Discord and it would tell people that there were a bunch of servers. And if we went to files and Terraform, and then this is my main.tf and Terraform for how we used to build out from my Amazon machine instance. And then we would go and I would build this user data, and we would change this every time for the password and the password authentication. And then we would set it up to be connected back to our backend file system and all these things. And this was just this whole, and then I would go and I would deploy all these Ansible targets and stuff and then report them out, right? Lots of stuff. All that to say that this is a repeatable, inheritable role inside of Ansible that then I could then inherit this and some other role, and it would go out and do all those different things. So, without getting too far afield, let's go do that in a very simple way, and then just know that you can be more and more complex with it. So this one here says, your team has been using Ansible and decided they needed to have better reusability and modularity to their code. They wanted to build something and use it somewhere else. That's what reusability is. And modularity is the idea that I can take something out and go put something else in. The best way I can describe modularity is if I had a big wall of Legos right here, right? And they were all yellow. And I said to you guys, I said, hey guys, do you think I could break this wall in half, this wall of Legos? Do you think I could break it in half and add a green line across the middle and then close it back up, and I would have a yellow wall of Legos with green? And most of you would go, yeah, dummy, you could definitely do that. And I would go, well, that's modularity. Modularity is I can add and remove components without affecting other components. Well, largely, right? There's some naming of indexing of things that might change or whatever. But, oh, by the way, my closed captioning has broken. So let's go fix my closed captioning real quick. Is it back? Is it back? There it is, back. All right, that breaks every now and then, and we got to fix it. All right, here we go. We're back. Galaxies. Let's go read over here. And it says, you've been tasked with testing and deploying galaxies to see how inherited roles work in Ansible. So we're learning some stuff about Ansible. Oh, by the way, I missed some stuff over here. Heather, I do the same thing. I constantly send them updates first, and then they get the point and stop. Yeah. There's different ways to deal with people, but if you ever, there's a really good book on, it's called Getting to Yes, and they talk about negotiation judo. And the idea is a lot of times people do stuff without knowing that they're doing it, or sometimes they do know, but either way, calling it out and addressing it is always the easiest fix. Because otherwise you're just the one that feels like crap, but you might as well make them feel like crap. I'm just kidding. But that's a thing from a book called Getting to Yes that's really good. It's a really, really short little read, but it's really good on like how you negotiate and how you talk to people. Scrum Masters, Project Owners. Yeah, you guys got to remember, the only reason they exist is to ask questions. They don't build anything, right? So they probably kind of feel sad. Yeah, there's a lot to do with communication for sure. Scrum Masters. All right. You've been tasked with testing and deploying this, so let's get this going. Isobu definitely done stuff without thinking about the other person. Yeah, I know people who they don't even think about it. They just talk over people in meetings all the time. I know people that do that. And some people will never talk in a meeting again if they get railroaded like that. And then for like the rest of the time you're on that project, you will never hear anything from them except in like a Slack message or like in an email. That's an engineering thing. There's our engineers that just talk right over people. You know, if anybody here ever works with me, and some people that are around in Discord have worked with me, I very rarely talk in meetings. Most of my stuff is typed. Most of my stuff is sent like that. But if I'm talking in a meeting, it is almost always something important. It's like does everybody here know what an entmoot is? It spelled it right. What's an entmoot? Anybody know? You can go Google it if you want. But in Entish, it takes a long time to say anything. So we only say things when we have something important to say. And that's what I tell people about if I'm talking in a meeting, most people that have worked with me are probably listening, because I don't talk much in meetings unless there's something to talk about. I want the things I say to have like some weight of importance. That's just because, well, one, I don't really pay attention much in meetings anyways, but let's create a directory called root playbook roles. So we ls in here, and we've got some stuff. Am I in yeah, I'm in Galaxy and roles. Okay. And so we're going to make a directory called root playbook roles, and then we're going to cd there. So pwd, we're in there. And then we're going to do, we've moved into that directory. We're going to create a couple of Ansible galaxies. So we're going to do an ls-l, and we'll see there's nothing in here. ls-al even if you want. And there's nothing in here. Now there's two things that show up, but everybody knows what the dot and the dot mean, right? If you ever do this in a directory and you say, oh, there's nothing there, but I've got these two things. These are relative paths. This means the directory I'm in, so that's technically the directory permissions of the directory you're in, and this is the directory permissions of my parent directory. So that's why that always shows up when you look for hidden. The -a shows you things that start with dot, and you always have the local path and the parent directory path. Those are always there in the directory. Okay, so I'm going to create an Ansible update. So I looked and I saw nothing in there, and with tree I saw nothing. Tree is just a tool that helps like newer administrators and engineers wrap their head around things, and I think it's useful in this lab. We're going to do Ansible Galaxy init update, and when we do an ls-l in a tree again, we're going to see that there's a directory created that has all the structure of things that we need to build a playbook. In specifically an inherited role inside of a playbook. So roles, playbooks, or root, playbooks, roles, right? We're also going to do the same thing for install. And we check again. Update has all of its self-contained pieces, and install has all of its self-contained pieces. That's it. Now we're going to go update some of those pieces to be able to do the things that we need. So we're going to go into the playbooks, roles, updates, tasks main. And in there, I'm just going to delete all of this and hit I to go to insert mode. And I'm just going to grab all of this. And inside of that main, I am going to inherit further. I'm going to include tasks of update.yaml. And the tags for that are going to be update. Now, tags only come into play if you choose to use tags. Otherwise, you run through everything in a playbook. But tags are a way to limit down to only certain things. All right, so now I've updated that one. And then I've got to create a file that was being referenced. So this is a file that was being referenced over there. And this file is going to do a very simple task, which is simply upgrade all the servers, upgrade all the packages to the latest package. Escape :WQ. And if I were to cd to this directory, now we've got a main.yaml, which was already there, but it's been updated with including the update.yaml in this directory. And then we do our more update.yaml, and that is one simple task that's just going to update everything. This is exactly the play that we did in the last lab where we updated all the servers. But now we're doing it down in an inheritable role that somebody could come along later and just use this to update all their servers as part of a bigger, longer playbook or whatever, right? So we're in here. We're going to go up a few directories. And we're back in roles. And then if we cd down into roles again, now there's our install and our update, right? Now we need to do that for the second directory. So we're going to go in and change the install directory. And I'm just going to hit DD to delete everything. Go to insert mode. And I'm just going to add, here's our install things. It's going to install, it's going to use the tasks install.yaml. I'm going to have to create that install.yaml because that directory doesn't exist. And in there, if we wanted to, we could debug variables. We don't have to do all that, but we're going to. We'll debug variables around the app that's part of the host file. And then this is the same thing as before. If you're the web server, you get this. If you're the database server, you get that. So now we hit check, and that part's set up. So we've got our roles correct. If we are in here, in update, we've got in the main.yaml, we call the update.yaml. You don't have to do that breakout if you don't want, but we did in this lab. And in install, we have the main.yaml that points to the install.yaml, and then we, in the install.yaml, have all the install pieces. All right, so it's all done. Now all we got to do is make a playbook to run this. So we're here in roles, we're going to go up one, and in here, we're going to make a playbook called environment.yaml. And this environment.yaml is going to do all the things that we need it to. Watch what it's going to do. It's going to go against hosts all. It's going to hit all the hosts in the host file, right in the inventory file. It's going to do gather facts true, because we need the facts. No special vars, no tasks. But then it's going to inherit the role update, and it's going to go down that path and do the update. And then it's going to do the install. So we're going to hit escape, : we already wrote it, so we can do that. We can cat it. It's environment.yaml in here with us. And it's just going to go inherit those roles, right? And then I say run the playbook to see how it works with no tags. So I'm going to say time. I want to run a timer, because remember, this is going to take like 5 minutes. So we're going to run a timer around it, and it's going to go and it's going to say, okay, in the update role, we're going to include tasks, and in the update role, we're going to upgrade all the packages to the latest version. This is going to take that additional time again, like it did in the last playbook. So it's going to take like 3 minutes, 3 to 5 minutes. We'll know here in a second. And then when it's done, it's going to go and update the environment. So it's going to go from update to the install role. And in the install role, it's going to install the web server and the database server, which, by the way, is exactly the things we just did individually. But now we're inheriting them as roles. And this role, we could go take this role and go put it in any other playbook in our company and update all our servers before we do whatever. We can install the web and the whatever if we have those variables set. And guess what happens if those variables aren't set in our host file? These just get ignored. Well, this one's going to run no matter what. But this one will get ignored. If you don't have those variables, everything will just be skipped down the line. So, very, very safe to run these. Because if somebody doesn't know how to set their inventory up, doesn't know how to call your servers, they can't go mucking around and running these. Well, they can run the update one. But the other ones, install won't work. If you don't know how to set those variables in your host file or set them as the playbook is running, it doesn't matter. All right. So that's going to run for a little bit, right? It's upgrading, doing all those things. Let's go ask our questions. What was created when you completed the first Ansible Galaxy command? So what was created when you ran the Ansible Galaxy? It's all lowercase. Command. The full directory structure needed for an inherited role. Everything that was needed was built. That's really nice. Then I say, do you see the expected output when you create the second Galaxy? And the answer to that in the lab was yes. We were able to see the full install directory structure because it was install was the second one we did, right? And that, by the way, that's running, so it's patching for a while. Up here, this was the install one right here. Big directory structure when we created it with Ansible Galaxy in it, install. So it goes by name. All right, boom, there we go. How did the playbook differ? How did the playbook you create differ from all the other ones you've created in the lab so far? What does it mean that it has a role? So how this question assumes you've done the other labs. How did the playbook you create differ from the ones you've created in the labs so far? There's a few ways it's different. It's roles instead of tasks. But funny enough, roles comprise of tasks. Tasks are the actual unit of work that Ansible does. It does tasks, and tasks call modules, right? We've been seeing that. But what if I told you this then? Another way it's different is roles are like functions in that you call them individually. So you call them individually, or more specifically, you inherit them in the playbook, right? You actually inherit the roles. That's what you're doing. Now it's going and doing the install piece, right? And then it says, what happens when you run the playbook? Well, a few things run. It inherited both roles. It took 4 minutes and 18 seconds. It inherited both roles. In the playbook, we knew what role it was in. So in the output, we could tell what role and task we were in. We could always tell what role and what task we were in as we did the update. The update had the include tasks that went to that file, and then still the update role, the upgrade all packages. And then we come down here to include tasks for install. So that called the install task, and then debugged all the variables, installed the web server side of things, and installed the MariaDB side of things. Hackplant said, since FIPS finds Paramiko objectionable, how do you enable SSH authentication with Ansible if you're working on Fed compliant systems. Hack the planet. I haven't ran into that problem yet, but I can tell you when I set up my when I've been doing Stig stuff with Ansible, I tend to be my Ansible playbooks are running in a chroot environment before I deploy my nodes. So I've not run into it yet where the government hasn't allowed me to do SSH anywhere. But I can tell you that when I'm building environments, my Ansible is typically doing a chroot. It's dropping into chroot and doing the configuration that way. So it's not breaking any rules if there were any. But yeah, I haven't run into the Paramiko problem yet. That looks like an interesting one. That's an interesting one. Yeah, I haven't run into that, unfortunately. So let's see. What happened when you ran the playbook? It gave us all the output. And then we had a time. And by the way, if we rerun that time, we'll go see it rerun through, and it'll only take like a few seconds this time. Like 10 seconds or something, right? 7 seconds. But it still inherited all of those roles. It did the update role and then the install role. And then it says we can run it with just the individual tags. So we could do just update. Tags for update will only inherit the update role. And tags with just the install will only inherit the install role. So it says here, what happens, what happens when you select specific tags? What happens when you select specific tags? Each run, only the role that is tagged for the tag is called. All right. And then it says here, would you create another role? Could you create another role and inherit it in this playbook? And then it says, where would you put that role? So could you create another role and inherit it in this playbook? Yeah, I think we could do that. So Ansible Galaxy init, maybe uptime, right? And then maybe we check the uptime of server. So let's do this. We go down to roles. We see the two roles. We do an Ansible Galaxy init for maybe uptime. And then we cd to uptime, and we'll see that whole directory structure. We cd to tasks, and then we vi our main.yaml. And I could inherit that. I could call out to that other path, or I could actually do it here. And I can say name, check uptime of all servers, right? I don't know. And then it could just be shell uptime. By the way, some of you have seen this in other labs. Register, uptime, check, I don't know. And then we debug it. So name is debug uptime. Debug is our module that we're calling, and the argument is var uptime check. So could we check the uptime of all the nodes? Now, real quick, I'm in here, I go up, and I look at my environment.yaml, and I say, if I run this right now, does that playbook, that Ansible Galaxy playbook called uptime that I just put down in roles, right? It's right here. Now there's install, update, and uptime. Is that going to run right here with the rest of this, yes or no? This is the playbook right here that I'm about to call. Am I going to have the role inherited that I just built in the roles directory called uptime? One test is worth 1,000 expert opinions. Daft Duck, you're right. The roles are not themselves being called. It is the individual tasks and the tags. Yes, that's true. That's very true. So check this out. On the environment, it did not run that. So let's go look real quick. VI environment. If I want the uptime, I need to inherit it. It needs to be one of my roles. Now I'm going to rerun that playbook, and it's going to do the uptime chart. Manage roles are FIPS compliant, then you have trouble reaching them with the latest standards. Yeah, hack the planet. I haven't run into that yet. I haven't. It's funny you say that. I haven't tried to actually do anything in a FIPS environment, so that may be something I'm going to have to work with. There are other ways to connect for Ansible. I'd probably have to look into those. Yeah, that's interesting. I haven't messed with that. However, can I tell you, it wouldn't affect me much in my configuration of boxes because I never push configurations. I always make them pull. So, using libssh, interesting. When I build boxes, and especially in government systems, I make them pull their own configurations with Ansible. So there's never an SSH. It's just a local host on the box, and every one of my boxes always run it. And then they bypass it if it's already configured. By the way, so that did it. And wait. Oh, well, it doesn't work if you have tags. You take the tags off. There's our install. There's our update. I don't know what I was thinking. And then now with our update, it does inherit the last role. So there you go. Boom. And then can you remove the update role from this playbook? Well, I think we could probably figure that out, right? You can just comment it out if you want. People like to comment different ways. Some people insist you comment over there. Some people, it doesn't matter. But you could comment those things out or just delete them. And then now it wouldn't matter what you tagged because this thing would only do that. And you can always, when you run a playbook, there's actually an interesting thing. Ansible can go through and look at all the tags that are there. So if I take this off, I believe, I haven't done this in a while, but I think I can do list tags. And it'll tell me, here's all the tags that are task tags, task level tags. I don't have any role-based tag, that's true. Install and update, those are the only tags that this would accept. I could add more, I can remove them. We can do things up and down all over the place. All right. So yeah, could we remove an update? Yeah, we could remove things. I think that's pretty straightforward. All right. Could you create another role and inherit it? Yep, we did that. So good. All right. So that is the simplest little kind of deployment that I could kind of think for doing the start of like an Ansible Galaxies and roles. The next thing we'll do is we'll set up a web server environment. And the web server environment, when we go into it, I'll link this for people that want to do it right here. I'll just link it. I'm not gonna pin it like I normally do. But we'll go in here, and this is gonna be a little more than just pushing a web server. This comes from, it says right here. This is a thing that happens in the environment. Create a playbook and push the Apache environment. Your team was so happy with your work on deploying a web server that 10 other teams have come and asked you to do that deployment for them. So if you go look at this deploying a web server, what we did in that web server lab that's over in the Linux labs is we stood up a web server. Cool. It's easy to make port 80 work. Then what we did was we added virtual directives and listen directives for ports, so we could listen on port 8080, 8081, and 8082. Then we set up virtual directives for servers to connect to each one of those, and we shared them out from different document routes and allowed somebody to come in on a dev, a test, and a prod environment in our web server. So that's what we did in this other lab right here that I'm referencing. So what happens is the team says, hey, we want to do that. We want to make that a standard install everywhere. And you're like, well, I'm not going to build all that crap by hand. That's too much work. So I'm going to make a web server available on Node 01, and I'm going to set up a directive and a web page that identifies each of the following. Dev is going to be port 8080, test is going to be 8081, and QA is port 8082. That's what we did. Make sure each HTML page exists and has the name dev, test, or QA on that page. These will be provided by the individual teams and put in the answers directory. So we're assuming that the teams gave us the web pages or whatever, right? We could also, in the web server, once we have the server stood up the way we want, let those teams go build their own crap in their web document root and all that, whatever. But it sometimes falls on you as the person that has root in an environment, the person who is the owner of all the servers to do this stuff. So we don't want to go manually building web servers. That's a hassle. I haven't done that in 20 years. But what we're doing here with Ansible is automating this process so that we can push and deploy and then eventually destroy and add individual pieces of this. Okay? So make sure all this stuff works, and then let's go. So we're going to check our host file. Here's our host file. Here's our web server, which is just node 01 in this environment. And then we're going to check that we have all the stuff that we need. Here's all these different pieces of this. Okay, good. And then we check one of them. Okay, it looks like a dev page. That looks fine. And then we look for the dev virtual host configuration. And here is a virtual host on port 8080 that is going to point to the right information that we need. So it's a dev error log instead of a normal log. We're pointing at the right document root, which is going to be a special document root that we set up. Okay, all the pieces are there from our lab. And if you say, Scott, I've never set up a web server before, I need help, go do that first part, and it'll make you do it all by hand. We're not going to do it right now because, well, deploying web servers by hand is no fun. So we can just, and again, you want an internal test, because you might say, well, why don't you just go stand up like a Linode or whatever. Well, maybe your company has security policies or security standards. You're obviously doing dev test and QA, so you've got multiple deployments. So maybe you want to test it in a secure environment. Maybe there's all kinds. I mean, who knows your use case? The point is, this is how you can do it, right? Let's create a file. If we want to, we can just copy this file in. But let's go ahead and, so I'm going to copy answers web environment YAML to here. And then I'll just cat the web environment.yaml file. And let's go look at all these individual pieces in here. They give you all the things. And right here we start with cat web environment YAML. Start up here at the top. 3 dashes means it's YAML. Web environment. We're going against just the web server. So that's just that one server. And we're doing all this. First thing we do, we install Apache 2. Make sure that it's there on the server. Good. Then we're going to create directories for the environments. And we're going to do a little thing here where we loop over the dev, the test, and the QA. And every time we step through that loop, we're going to have whatever this item is here is going to be named item. And the item right here, so the first loop is going to be var www.html underscore dev. Then it's going to be var www.html underscore test, and then underscore QA, right? Simple loop. And when it's done, it's going to notify that we need to restart Apache. So we installed Apache up here. And this is going to say, go ahead and flip that light switch on, that when we get to the end, we need to notify the handler. We're notifying what's called a handler. And the handler is going to go restart Apache if it knows how. Good. Then we come down here. Next thing we're going to do, we're going to add listeners to Etsy Apache 2 ports.conf. So we're going to go to that file. We're going to loop over listen, and we're going to add that line, if it's not there, each time to that file. So we're going to loop over that. And if that has any, by the way, if this has changed, meaning you had to do anything, it's going to notify. If it's okay, it doesn't notify. The notify doesn't notify the handler. Same thing here. If it does have to change anything, it's going to notify that handler again. But like I said, it's flipping a light switch on. Have you guys ever walked in a room and flipped on a light switch? Have you ever done it after somebody else already came in the room and flipped on the light switch? Let me ask you this. Does the light turn on any more than it's already on? The answer is no, right? So where I'm going with that is, if you turn on the light switch here, and then you also say to turn on the light switch again, the notify, the handler is only going to do the action once. So don't think it's going to do the action here and then do the action here again. It's not going to work like that. It's only going to do it once at the end of everything. So we come down here. We're going to push the virtual file directives into the correct place. So we're going to loop over dev virtualhost.conf, and then we're going to get that from the answers file, and then we're going to go put it in the destination correctly. Good. Then the last thing we're going to do is we're going to push over the HTML, and this time the loop is a little different than the others. All the other times the loop was just a simple item each time. Now the item is going to contain a, in the loop we're going to have an environment dev and a name of the file, right? So up here, the source is going to come from item.name, which is here. But over here for dev, for the destination, it's going to get the environment, and then it's going to be named index.html. So we're switching the names as we write to a different directory each time. That's how that works. And again, restart Apache. And then at the end, we have a handler that is told how to restart Apache. That's it. That's the whole playbook. There's 4 things happening. They're happening against multiple loops, right? Multiple things are happening. But if any one of them has a changed value come out, the handler will restart Apache at the end of the playbook. If we run it again and none of them have anything to do because it's all correct, Apache will not restart. So you might say, why does that matter? Well, let's say you got 30 servers, right? You got 30 servers in your playbook. In this case, we only have the one, but we have 30. And we run it the first time, and it works on 27 of my nodes, but 3 of them break. And then I go, oh, shoot. Those have the wrong repository. Obviously, we can't install Apache. So you go and you fix the repository error they have. Or they've got something weird happening with them. So you fix those 3 nodes. Well, now you're in a position, you're doing a change. It's probably like a Thursday night, late at night, because you do changes in the off window. Or, maybe it's in the middle of the day. But the point is, you have 2 options here. You can go remove those 27 nodes from the inventory so they don't get touched again. Right? This is how we used to do it with like bash looping scripts and stuff. You have to go remove all of those. But now you've got a different inventory, or you've got to split that inventory and make a new one. It's just a hassle. But with Ansible, because of the fact that these things are idempotent and those things aren't going to have to change, I just run it again. I fix those 3 nodes and I run it again. And against 27 nodes, it just says okay, 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 okay. And on those 3 nodes, it says change, 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 change. And we only restart Apache on the 3 nodes we need to restart it on. That's a pretty good deal. That's a pretty useful tool. That's why people are like when we joke around about the cult of Ansible, that's exactly what we're talking about. Like the idempotency of I can not change, because I'm telling you, late at night, you're doing change window, you're in a change window, you're patching servers and you're doing this stuff, and you're manually pulling servers in and out of that thing that you got as a list of 300 nodes, you're going to fat finger something. You're going to make a mistake. The next morning, people are going to be asking you why one server in prod didn't get patched, and you're not going to be able to patch that damn prod server, or you're going to have to take like now real customer-facing downtime, or you're going to have to go that next weekend and waste your weekend because you messed up. And you messed up because you were making changes. You are always going to make changes when you're hungry, angry, lonely, and tired, right? That's the HALT acronym. You guys ever heard that? Hungry, angry, lonely, and tired. If you're working and you're hungry, or it's late at night, or you're angry about something, that's when you make mistakes, right? That's the HALT acronym. If you've never heard that, that's called the HALT acronym. Yeah, I got it. Okay. So anyways, let's run it, right? We've done enough. We've talked enough. We've looked at all the pieces. We know what's supposed to happen, and then we can copy it in if we want to. And let's run the playbook. All right? Yeah, Isobu. There's an old thing. I actually heard it from a pastor years ago, but it's like don't make decisions when you're hungry, angry, lonely, or tired. So that's where I got that HALT acronym. But it's true. You shouldn't system admin when you're hungry, angry, lonely, or tired either. So that's an important concept to understand. All right, look, it's making all those changes. Now, if it's changing, I expect it to notify the handler. So it restarted Apache at the end of everything. But, hold on. If I run this again and I know those are all right, do I expect the handler to come up the second time? So let's run it again, right? We call it idempotent and we have this cult of Ansible. Is it good? Nothing changed. Nothing changed. Nothing changed. I do not expect to see the notified handler. I don't even expect to see it there. Look, up here, handler. What did the handler do? Restarted Apache. Down here, nothing. If I had more servers that this was running on, you would be getting all of those changes on all those servers, and only on the nodes where something changed would you get the handler called here. Super useful, guys. Super, super useful. It's a big part of why people are super involved with Ansible, why they like it so much. And if you go do that other lab and see all this individual stuff that we went and changed to make this other lab work right, you'll go, oh yeah, I'd prefer doing that with Ansible. Because you're gonna make a mistake. You do this You go do that lab 10 times in a row, and I guarantee you make a mistake. Even though you're just hitting buttons, you're going to make mistakes. You're going to skip. I've done that lab live, and I've skipped things. And people are looking at me like, God, this guy, he's fucking skipping. Like they look like Ben Affleck out there smoking. You know, the Ben Affleck, like that meme? That's what they look like watching. Or they're that guy going like this, just watching me mess stuff up. Because you're going to make mistakes. It doesn't matter if you wrote the lab. Easily replicate my infrastructure with LXC and Terraform and Ansible. Nice. Nice. Yeah, I used to do, I showed you guys earlier, but I used to stand things up and tear them down with Ansible out in the cloud for people. I moved away from that because Killer Code is such a good lab environment. I don't really need to do that anymore. All right, so we did all this, right? We did all the pieces. We made sure that it worked. We ran it twice. And then now the last little check is, well, is it there? Yeah, there's our web pages. We curled all the web pages, and the dev page is the dev page, the test page is the test page, and the QA page is the QA page. Why did we want that all on the same web server? I don't know. Maybe we're constrained for resources. Not everybody has an environment where they can just stand up all the little virtual machines that they want. In fact, in bigger organizations, we do kind of constrain our devs to, hey, you can only have 10, and 10 may be a lot, by the way, but 10, you can only have 10 nodes yourself in your dev environment. And maybe some of you are like, 10? Shit, I got to use WSL in my own lab. Joaco on Prime. Hopefully this stuff's useful to you. Thanks for that. You know, you guys can use your Prime anywhere, and you use it here. That kind of feels good. But hopefully you don't get any more what the hell are they called? Ads. Hopefully you get out of the ad space, because I know I got a lot of ads, and you know, that's Twitch for you. I think on the YouTube side it dumps a lot of ads on people too. But okay. But we're asking ourselves these questions. So we did all this. So we changed the variable. Did I answer any of these questions yet? No, we got to start answering questions over here. So this is the part where we ask ourselves questions. What is the package needed to run a web server? Well, we needed Apache 2. Apache 2. And do I know how to go... Whoops, Apache 2. Do I know how to find that information? Yeah, I can just cat my... Where's it at? Web environment. Cat web environment.yaml, and there is my Apache 2 package that was installed by apt. All right, good. So that's how we did it. And then I said, what are the directories that are created for the web root? Well, the web root is var www.html whatever, and I know that because then in each of these dev directories, that's where I got it. So what are the directories created for the web root? And some people call this doc root. It just, I mean, some people, it just depends on the environment you're in, right? I think of them as web root. They are the var www HTML underscore whatever, in my case dev. When we did it in bash, we did dev test QA like that, QA. And when you do that, that is a wildcard for when you made those directories, and it would make each of those at the bash command line, right? Hack the Planet said, am I a fan of coffee? No, I actually drink Monsters more than I drink coffee. Oh, by the way, the wife texted me. Hold on, I gotta see what the wife's saying. See what she wants for food. The wife said she'll go get me food in a little bit. So I'm seeing what kind of foods does she want. She wants to do a drive-through, so we don't have to stop anywhere. I don't have to go with her, but I mean, let's see what the wife says. We'll wait that. But yeah, no, I don't really drink a lot of coffee. I'm more of a Blue Monster guy because there's no calories in it. But I've never really drank a lot of coffee. What are the counting variables? What does the counting variable change when you push over the HTML for each page? So it's a counting variable because we're looping over things. But when we push over the HTML for each page, that is actually done down here. And I said, what is it changing? It's changing the name to index.html, and it's also changing the directory each time via the item.env variable, right? And you can see that happening right here. So in the source, we call answers and then item.name. So we're calling the name here. So the dev underscore index.html. That's where it's coming from. But when we go and put it there, when we go put it somewhere else, we're calling it index.html. So all of these files, when they're done, are called index.html in the directory. They don't have this prefix on them. So then the environment over here, which is dev testing QA, is var underscore www.html, var www.html underscore item.env. So it's dev tester QA with only an index.html, which maps up here to what you created. So you created the individual directories straight out. But when you put the files over there, you took these different environment files that you had and you renamed them, but put them in different directories. It's not like, guys, it might look clever because you didn't see me write it, right? Because I did it, you know, when I built the lab. It's not that clever. It's just a cool little trick that once you do it once, you're like, that's it. Yeah, that's all it is, guys. That's all it is. We're not doing anything here that isn't simple enough to just explain. Make me a coffee. Sudo make. Yeah, that's funny. Hack the Planet. There's a version of that. So for people that like the old sudo make me a sandwich, this has been around the internet forever, right? And I believe it originally came from XKCD, but I could be wrong. Yeah, I think it's XKCD originally. And it's 149, so that was really early in the XKCD world. But have you guys seen the modification of this? There's a pretty funny little one that'll come up if we go to images. I love it. It's so there's this and there's a billion of them, but then hold on. There's this one. Well, this is a version of it, but it's not a good one. What's the password for user? And then thanks bye, and it doesn't do it. But there's one user is not in sudoers file. This event or this incident will be reported. That's one of my favorite little ones. Where's that? Somebody's always got that one. Sudo make me a sandwich. That one's been around forever. Anyways, I don't see it. But there's all kind. Man, there's like a million different modifications for make me a sandwich, sudo make me a sandwich. But that's an old internet reference, guys. I mean, if you're only like 140 something on XKD, that's a long time ago, right? Okay, so now look, you've done all these things and you've made everybody on all the teams happy, but then, right? Success breeds more work always. Now the teams want the ability to turn off or redeploy only parts of the environments as needed. So now they want to remove. They're like, hey, I am only doing dev and QA. We don't have a test environment. We don't want that port open for security reasons. So now teams want to pull things in or out based on whatever. They want each piece to exist independently of each other. So now break out the playbook and turn off the listener for test on port 8081. So now we've got to take this, what was pretty simple, which was just a deploy, and now we've got to make this both deploy or remove things. So this is the first time in all the labs that I make you do a block module. So block is right down here at the bottom. We're going to do a block module now. So we're going to clear the screen up. That stuff should be clear as mud. If it's not clear as mud yet, spend some time with it, right? And the next thing we're going to do, we'll go ahead and copy over this individual web environment thing. And I'm going to show you, there's a lot of ways we could do this, but I'm going to show you one way to do it, and it happens to be the way that I chose to do it. Is it the only way? Absolutely not. Are there better ways for guys that are computer science majors? Sure, right? I'm just a guy that does Linux, right? But here's how I did it. I added some required variables. There's a little note at the top. These are all notes. And it says, you must tell me if you're deploying with present or absent, what you're doing. Then you need to give me an environment, dev tester QA, and you have to give me a port, and that port must match the spec given by the teams, which is dev test and QA. If you give me other stuff, this will probably still work, but it's going to break the shit out of your environment. So let's put that as a level set, because there are levels to this, right? But it's going to be the same start. It's going to be the same start. Then we come down here and there are blocks. And the block is for to deploy. If you tell me you want present, then we're going to deploy. And when I wrote this, I used to use this standard where I put the when at the bottom because that's how it was always done in Ansible. But nowadays, if I were to rewrite this, this when would be right up here under the name. So it'd be name, when, block. Because this is kind of weird, like looking at the condition at the end. I know. But if you give me deploy as present, this block up here is going to run. If you give me deploy as absent, this is going to run. And no matter what you do, if anything changes and alerts the restart, the handler will restart. Okay? But only do it once, no matter what you give me. So we come up here, and if we're saying to deploy, but that's not what we're going to do. We're going to actually tear something down. So we're going to make something absent. It's going to delete the directories for the environment. So the environment you give me, so let's say you say QA. QA is going to get deleted right here. So you gave me a variable QA. We're going to remove QA. Then you want to remove the port. Well, you better have the right port for QA, because once you do, we're going to remove that listen for that port out of the environment. Then we're going to delete that directive as well. And after all that happens, we're going to restart Apache. If, however, you need to turn it back on, you're going to come up here and you're going to give me that environment, and I'll put this back, and I'll add the listener back, and I'll push the virtual directives, and I'll build the web page like we originally had. But without the looping, right? There's no looping anymore because there's no loop. There's only the one push or the one delete. That's the only thing we're doing. Again, you might look at this and go, I got better logic. It's fair. By the way, if you look at this and go, I have better logic than that, now you understand Ansible. You understand why this has so much like use and power that people use this. Hold on, I gotta check something, guys. Sorry. I try not to play on my phone too much during stream, but the wife is messaging me. Okay, see what the wife says. All right, so this is one of these things. We could watch this and look at this all day, but let's go run it. So now we're going to run it, and when we do, we've got to give these extra variables now. So I'm going to say deploy absent, environment test, and port 8081. So rip this stuff out. All right, let me see. I got to send my... give me 1 second, guys. Give me 1 second, guys. And all right. Okay. Sorry about that. I'm going to run this, and it's going to give those variables, and it's going to rip those pieces out that we don't want. Look, it's all these other things that it skipped that whole block at the top because it wasn't told to do it. So it's only running the block at the bottom. It removes the things that it doesn't need, and then it tells us that's done. And then I should be able to go look. I'm going to press up a few times, and I can curl 8081. That's still there. And I can curl, we just curl 8082, and that's still there. But 8081, that's no longer there. We ripped it out. Now, could we put it back? Sure. We could say present, and we should be able to say deploy is present. And now this should redeploy the correct pieces, only the pieces we wanted, right? And then it should restart the Apache handler, and now that should work again. So we ripped a piece out, we put a piece back. Now, this part again, not the most, you know, this is one of these things where this could probably be logically better, but it was a quick and dirty way for me to acquiesce a team, This is one of these things that we might call almost like a one-off logic. I wouldn't have spent a lot of time as an engineer on this. The reason I would have built this for myself was so that if any loopy team came at me with any loopy crap, I could add or remove it. Now you might very quickly say, wait a minute, Scott. What if they came and said, we need 8084 with like prod. We need to test prod. And I'd say, all right, yeah. There's a few pieces of retooling that we have to do. Like you might notice in answers, there are things that are not being built by Ansible in this. Like if you look at the dev, so let's look at this, more dev virtual. There are things in this that are not being built by Ansible. This was not being built by Ansible. Could we have built this via like a Jinja template and put in the variable here for the port and also down here? Yeah, we could have actually done that. So we could make this better in the future if we wanted to. And these things that are all these individual different files, I could do those just as Jinja templates. I could do that. I didn't do that because, again, maybe I was doing other stuff and I got pressed to do this by management and they're like, hey, everybody loves this thing. And you're like, all right, screw it. I'll go deploy this thing a certain way. And this is maybe, how you would do it. So look at you learning Ansible. You created a playbook to deploy a web server for development teams. And then you created a solution that allows them to remove or add things. You guys got to remember, the things that come at you as an engineer are very rarely like, I tell people all the time, I don't know what I'm going to do today or tomorrow. I'm going out. I'm actually going to be in a skiff out in Chandler, Arizona. I'm going to be working down there in a secure facility. I generally know that I'm building a high-performance compute cluster. I generally know what I'm going to be there for. But what I'm going to be doing for the next 2 weeks, I have no idea. And you say, well, Scott, that's silliness. You start here, you end there with a cluster. And I'm like, yeah, but this is what the tasks are going to look like. It's going to be like, you guys ever seen that comic that used to come back in the day? We used to read newspapers, right? And there was a comic section for kids. And there was one called, I think it was the Family Circus. And the kid would always walk around everywhere like this. And then they'd be like, what did you do today? And he'd be like, oh, I was bored. And it shows him just like wandering around. And that's how I feel like it is a lot of the times. Now, is this good enough for me, in a quick deploy environment and just getting that stuff for a test? Yeah. But then if you said, Scott, would you use this if you were going to go take this and put it into like a Ansible automation platform, and this was going to be a deployer that was always used by like your bridge team to help stuff to offload your work? I'd probably work on this a little bit. This needs some work. Does it work in a pinch? Does it work for the lab? Does it show you all the pieces? Yeah. Would I productionalize this? I'd work on it some more. And I would make some of the logic better around how I pull and push, especially this, right? Because you could just not give me those variables and this thing will break all over the place. I give you a warning up here, but I also have, there's warnings you can give in here. There's messages that you can give, and if variables don't exist, you could just fail out early and tell people, hey, you're a dummy. Whereas like this requires you to know to go read the file, right? Not everybody knows how to read stuff. Block monster, I can't understand whatever that is. Like, I think oi is, I don't know what that is. I don't know what that language is, but I can't help you unless you speak in English, unfortunately. So, Mr. Muddy Pants, it's oftentimes better to have something that's readable and easy to use than perfect Ansible. Yeah. And some of you guys have heard my kernel graph, and kernel graph's not a real human. That's COLONEL, right? Kernel graph. He's not a real person. He's a person from Ender's Game, right? But there is General Patton, who's a real person, and they both said, General Patton said a good plan violently executed now is better than a perfect plan in the future. And then another one that was said was, again, by Colonel Graff, who said, you're never ready, you go when you're ready enough. So there you go. DDoS, how's it going? Hopefully this stuff's useful to you. I don't think you've been in here for a while. But hopefully this stuff's good. We're getting near the end of what I have time to do today. But we're going through and we're asking questions. And we're working through stuff. So it says right here, when you execute the play, how many times does the handler section execute? The answer to that is only once. at the end only if needed. It's the only time it runs. And then I say, what does the block module do in Ansible? For us in this one, all the block module did for us was basically create, in our case, we used it as a function. You either went to this function or you went to that function, if you want to think of it like a computer science person. But what if I told you that there's all these other things? I actually have to build a block module. I need to build just a thing on this. And I do not, let me tell you something as an engineer, I do not use block for all the functionality or nearly as well as I should. There are so many things. So in this case, the very first thing they say is grouping tasks. That's what we used it for. We grouped them all together. Then they have the when at the bottom, but I'm telling you, I'm going to start putting the when at the top because I think it's easier. When the Ansible fax distribution is sent to OS, it does these things. But you can handle errors in blocks. So I'm going to grab this real quick. I'm going to link this to people that want it. And then down here, hold on. Give me a second. I'll answer the question after the ad because I know there's that. And then there's rescue. And rescue and always are things that can happen only if failures occur. And like, look, print an error. I caught an error. Force failure where we can go and then we try to, in this case, never print this because you don't end up having, because we forced a failure in the middle of a rescue block, right? So then this never gets printed. So there's like all this cool logic stuff that they show you in here that I don't even use this for this. I literally just use it for the first thing, which is right here, grouping tasks together. This is one of these things where I say I'm trying to get better with these tools as well. So I need to spend time in there and maybe even build a lab where I go do some tests around that kind of stuff, but where we do more than just grouping things together. Okay, by the way, so we're back from break. There was a question by DDoS that said, question for you, probably heard it 1,000 times, bachelor plus skills or just skills and work experience? All right. So the heart of that question is, how do you get kind of like into the industry? Should you do bachelor plus skills or should you just do skills and work experience? So for me, the way that I broke into the industry was I just had a certification when I started 20-something years ago. I had gotten a CCNA when I was in the Army, so I knew all about programming switches and routers, and I got into networking when I got out. The job I had in the Army did not teach me anything useful in the civilian world. I was an infantry guy. I was just running around with my rifle. If you don't know, that's not, even in America, and even in Arizona, that is not highly recommended to just run around with a rifle. That's probably going to get you looked at a little bit. So that being said, I got a lot of my skills from in the industry. I think that you can break into the industry just fine without a degree. But as I say that, I also have a whole bunch of degrees, and I also teach at a college. So I'm a big fan of college, right? I'm going back and forth like the Sicilian in Princess Bride, right? Like clearly you would have put the poison in front of me, clearly whatever. So anyways, my point is, what I would do is I would start, my advice to anybody that's not in the industry now is just get started. I don't know where you're at, but start building up some skills by getting your hands on these systems, free labs like this, all over Killer Coda. You don't even have to like my labs. Go find somebody's labs. Go do labs. Get your hands on it. Then start building up a resume around how you can prove that you have those skills, right? If you want to get into the industry. Bachelor is going to take you 2.5 to 4 years, depending on where you go to school. So that's out for a lot of people that want to get in right away. What am I going to do? Tell you to call me in 2028, tell you how you're doing? No. I would tell you, start getting skills, start going and finding people that you can hang out with. We have a Discord. You're welcome to hang out there. But start putting things on your resume. We've got a little section, beginner start here. Go get certifications. These are all free certs right here. You can go put them on a resume. And guess what's better than not having anything on a resume? At least having something. API ones, somebody just told me the other day they really like this one. I liked this one when I did it a couple years back. Chaos engineering, that sounds cool. Can you explain chaos engineering to somebody? You will after you take that cert. So if you're in a resume, if you're in an interview, you got past the people, you put down that you know some Linux stuff, and now they're asking you, hey, what's this chaos engineering thing? You go, oh, well, it's just a method by which we ask questions and test hypotheses in an environment to see what happens when certain failure conditions occur. It's just another way of testing failures in an environment before it gets to production. That's exactly what chaos engineering is. And people go, this guy knows about production. We run production, right? Oh, maybe this guy needs to be one of our sysadmins. It's just, it's one of these things where, if you're asking me how to get in the industry, start somewhere, right? Don't just sit around and wait for people to get you in there. All right. Looks like Isobu and IO Fault might have answered your question a little bit as well. That being said, though, having a bachelor's degree, having masters, I'm working on a doctorate right now. All those things are sure going to help. They're going to make people look at your ability to go sit in the classroom differently than maybe others. And some organizations require that. Like if you want to go work for the big engineering firms, you need to have a bachelor's degree, at least in an engineering discipline. In a lot of cases, you need a master's. But that's not true of a lot of the companies that just want people who can code or do whatever. So you gotta get experience. There's a lot of ways to do projects and build a portfolio. I have all that stuff down in the Discord as well. All right. So where do we go? We did all this. All right. So that lab's done. We are not going to finish this today. The next part is going to be package cleanup. We're going to package clean up our environment a little bit. And that's probably where we're going to stop for today. But for people that stuck around with me, we're working on learning how to do these tools. We're asking ourselves questions. All these things, if you notice all of these labs, my questions are designed to make you think about what you're working on, right? DDoS said, love your labs in Discord, already using them. You're living in Germany, yeah, and you have to make a decision to go to university or start working. And the feature planning's coming to the USA. Yeah, I would just tell you, get your hands on stuff. At the end of the day, what's the barrier of entry to getting a job? You have to prove to people that you can do the work and that you will do the work. That you can do it and that you will. So can do is pretty easy. I can show that, I know how to set up a Linux box and I know how to do this and this. But then will I do it is more of if you're working in a lab and you're showing that you have kind of these progressing skills, I think that starts to look good. Even if you just put on there, look, if you put on a resume, I completed 400 labs inside of Killer Coda. What's the worst somebody can do? Oh, what is that? And you go, oh, well, I did a whole bunch of labs and I learned a lot about Linux, and that's why I'm sitting here, because I know all kinds of, things about Linux, because not even me, you go to do this Powaz or whatever his name is. You went and did all his stuff, and they're like, well, what's it mean to do, what's the path inside of Linux? And you go, oh, okay, I've set some paths before. Okay, path is all the locations that your bash shell is going to look for the execution of a command when you call a command by name. And they go, okay, well, what does that mean? You go, well, you can actually set your path. You can break your own path. You can do all these things, right? And you give people information that shows that you know how it works or whatever. Is he adding more to these? I swear he's just got the 20 and then the test. Okay. All right. Let's go check on Ranger. How's Ranger doing? He's laying around being lazy. We only have a few more labs, but I'm still not going to get to them all today. So here's what we'll do. We'll go find somebody to raid. I appreciate you guys coming by. People on YouTube that stuck with me. Hopefully this stuff's useful to you. People on Twitch that stuck around, find things that are interesting to you. Find things that you can build and, get in there and do it. I think you guys can be successful in this area and do all this. Also, I missed AI generated duck. Hopefully this stuff's useful to you. Let's go find somebody to raid. Who's on right now? Who's doing stuff? Let's go find the people that I'm following. Who's on? Let's go raid. We'll go to a high energy streamer. This guy's not in science and tech, but I like raiding him because he's pretty high energy. We'll go hit up Ross. Daft Duck, I appreciate you sticking around. Yeah, by the way, I really like your insights. You ask a lot of really good and useful questions from somebody who's definitely paying attention and and in the industry likely too. So I do appreciate when you're around in case that's not clear. So okay. Let's go raid out, and people on YouTube, it'll just drop. But again, you guys are welcome to hang out in the Discord anytime. All right, take care, everybody.